Sunday night. What's up, guys? If you are watching this after the live has already finished, if you're watching this as a video, then skip forward, because we are just getting started and waiting for my live audience to arrive. Sunday night. Da, 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 da. Oh, we've got people in the live chat already. We are cooking. We are starting. 1, 2, 3, 4. You guys jumped in here quick. Hey, how's it going? Man, why? Where does... Right. YouTube usernames these days be like hard to pronounce, man. Hello, my friend. Brendan. Very normal name. Thank you. How's it going, my friend? With a gecko. Yo, love it. YouTube, how's it going, man? Sean Barlow, how's it going? Good to see you there, my friend. From Ireland. THW Andy. So just out of interest, what's THW Andy? Where did that come from? Is there a way to pronounce that as a whole? Or is it like Andy? Maybe you meant to type the Andy and it was a typo. Like W is right next to E on the keyboard. Yanis, I think that's how you say that. Hi man, how's it going? Josh Holden, yo, what's going on, bro? What's going on? Hey Sam, do you know anything about the NVX XAD17 13.5K 4-bridge? My initial answer is no. However, you've said two things in that comment: 13.5K and full bridge. So there is a generic PCB layout from the Chinese build houses, which they always sell as a 13.5K, and it is the same crap that's in the B2 Riot and the Sundown SFB 13.5K and the all of these other like just sound digital clones. So by the sounds of it, it's probably one of those, in which case not a fan. Design flaws. Roaming around. Well, that's standard procedure for you there, my friend. Is there ever a time when you're not? Yo! Samwave02's in the house! Live from Ghana! Boom! Big man! What are you saying? Good to see you here, my friend. Greece! Oh man, love Greece. Greece, one of my favourite places. I challenge you to say my name. Nah, bro, it's not happened. It's Moran? Right, do you say it like Moran or Moran? I feel like Moran is like the British accent version. Oh mate, how's it going, Moran? But in Japanese, kana. Yeah, no, that's definitely not an alphabet that man recognises up here still. El Fuego! That's an easy one. El Fuego! From the Pacific Northwest. Man's in the middle of the ocean, bro, still. How's it cooking? Originally from Germany, there was an organisation called Technisches Hilfswerk. Short. Oh, THW. Okay, it's called Federal Agency for... Right, so that should be in capitals then. THW. Nice, love to see it. Thanks for the explanation, I appreciate that. My man William from London, yo, London town. What are you saying? What are you saying? Big Ben. So this evening we have a few bits and pieces. Actually, you can't actually see it behind me. No, hang on a minute. Scoot this over. Oh no, I'm actually at the limits of my camera. Behind me we have 1, 2, 3, 4, 5 amplifiers I'm going to try and get through this evening. May happen, may not happen, but they're all amplifiers which I am very familiar with. So, provided I don't take too much time chatting crap on the live chat, we might actually get through some of these. These are all amps that I've done before and stuff. We're just going to have a little chill sesh. We're just going to have a little bit of fun this Sunday evening, as we do, weekend vibes. My boy with the 50, sheesh! Sinewave02, man. Did you borrow them dollars from your fans? Like, yeah, that's a private joke. You get it. I'm joking. Man, with a 50. Thank you so much, bro. Honestly, what are you doing? You already freaking sponsoring this guy here too much. £50. £50. Coming in with a pink strip. And we get a 5 from El Frago. No, seriously, Soundwave, I appreciate that. You don't have to do that. Okay, I appreciate you. You don't have to do that. That's so kind of you though, man. I'm glad that you feel like you want to do that. But that's crazy, man. Big love, man. Appreciate you. Cheers. And El Frago with a 5. Thank you so much for the 5, my bro. I really appreciate you. Thank you so much. You're always jumping on my live streams. I always see your name pop up. So thanks for your support. What a scope for a beginner and prepare guy. Genuinely, what I would recommend if you're just starting out in repairing, you want to get yourself like, you know, a bench setup, like a permanent bench setup. Don't go for like handheld devices. Don't go for a handheld scope, a handheld this, that, the other. Try and get yourself as many like permanent fixture devices on your bench as you can, because they just work better. They don't move around your desk and stuff like that. So I would recommend for a beginner getting into repairs and stuff, an oscilloscope with digital function. Okay. Now you can either go for something old school, like the one that I've got myself my old ass HP here. Now I actually, although I love this scope to death, because oh man, this scope is a bit of me. This scope's been with me right from the start before I knew anything about electronics, and it's kind of taken me through and allowed me to. Oh, wait, we see just quickly. We got the melty aluminium. How am I even gonna get that off? Okay, there we go, easy. That has melted. You can look up the melting point of aluminium, by the way, if you like. But yeah, this scope has got me to the point where I'm at now. So I have big love for this scope. But to be honest, technology has come a long way, and you can pick up a scope with basically the same functionality as this, with a bigger color screen, which does help differentiate between channel A and channel B, for example, for not much money. For basic amp repair stuff, you don't need anything. You don't need anything with greater than like 150 megahertz. You can get away with 20 megahertz, but try and go for like 150. Obviously, the more the better, because you know you get more detail in the waveforms as you progress and you start looking into things deeper. But for basic audio troubleshooting and class D troubleshooting, 50, 100 megahertz probably do you just fine. And you can buy a lot of brand new scopes from like AliExpress. Just get yourself like a 2-channel or 4-channel, 100, 150 megahertz with all of the, and if it's a modern one like that, it's going to have all the measurement functions. So you're going to be able to see VRMS, duty cycle, frequency readouts, all this stuff, period, all this stuff. So yeah, just something on your desk that you can see, nice big screen, and you know it'll be fine. You'll be able to use it. I'd actually like an upgrade. I'd like a scope upgrade personally. I love this thing to bits, but yeah, I'd love something that has a color screen. Slightly bigger screen and a color screen would definitely help, I think, for me. What's up, old lad? Pip pip cheerio! Oh, these nuts, my guy here puts out some hilarious, what do you call it? Brain's gone dead. Parody videos. How's it going, my friend? Good to see you. Happy Sunday, my friend. Hope you're doing well. What are you up to these days? What funny sketches you got in that little brain of yours? Here in Italy, it's very popular. Many brands use that PCB. Yeah, literally every freaking man and his dog is using that PCB, and it sucks. It is not a good one. I would avoid if you can. What are we sipping on this evening? We're sipping on the old Malbec. We're sipping on the old Malbec. Malbec. There's a bunch of screws in these ones. Now this is the Chinese clone 5K PCB. So this will make a genuine 5000 watts RMS into 1 ohm. For how long? Well, I don't know. Not very long. But it'll do it. And the beauty about these boards is that these amps are so cheap, man. It's, even though they're not the best, like, it's kind of hard not to recommend them a lot of the time, because, like, you know, if someone just wants a bit of bass and they're not planning to keep the system for more than a couple of years, you can buy these boards from various different brands for like $250, even less. I'm pretty sure Soundcubed had these on mega cheap at one point. These amps are so cheap. It's kind of a no-brainer. And provided the company you buy it from has a decent after-sales care, warranty, all that jazz, then you know, these aren't a bad purchase. Mendip Mark has a bit of an overkill bench setup, in my opinion. So what he has though, which would be very useful, is for a lot of main stuff, and that is he has a lot of power supplies for voltage injection. For like, so basically, if he's trying to diagnose a circuit, he can inject about 8 or 10 different supply and reference voltages to get a thing sort of powered up without having to run it off the mains, for example. He's got a lot of really old school kind of scopes. I am not a fan of the really old school analog scopes. I know that they have their place and they can be better than the sort of digitizing scope, the digital scopes in some respects, but having used one myself, I actually do have an old school analog scope. Not a big fan compared to the digital ones with all the readouts and you know, the ability to kind of control the waveforms in a better way. But yeah, man, the guy's a legend, does incredible work. He's based here in the UK as well. I'm sure, like, you know, if he had some reason for us to collab on something, then I'd love to. But I don't think he does. Like, we're both very similar. We're both doing similar things. There are things that he's definitely a far more experienced technician, and he's not only a technician, he's a perfectionist. Like, he will repair all of the cosmetics, like looking factory, like with all the like seeing like the lathe and stuff, and he'll like make new external and cosmetic parts and stuff, which I am not doing. I just make circuits work. I don't have the workshop bench top skills, abilities and equipment to do all of the cosmetic stuff. So but he is like an all-rounder, does everything, you know, refurbish something back to factory cosmetically and electrically. So that's, yeah, he's a legend, absolute baller of a guy. Please can you post up the STL files from the Boom or Bust? I want to print the HT tuber. Yeah, if I can find them in my email. It's a long time ago. I'll have to see what I can find. Keep reminding me. There's not really any reason to print the tuber HT though, unless you want like something that peaks in like the 160, 170 hertz range. Like, there's no real world application for that. It's not a subwoofer. Yeah, you can't really integrate that into any real audio setup. It's just a thing that exists for Boom or Bust, pretty much. Right, well, just real quick, what do we have going on here? We have so we have a cooked power supply, absolutely cooked power supply. The output MOSFETs in the output side are labeled H9. Now, why do we have cooked power supplies? Is that because the outputs are dead as well? Looks like we have is either flux or burning. Look what we've got over here, a visual inspection in the drive circuit here of this channel. Now, it doesn't immediately look like burn, it just kind of looks like flux. But you don't usually get a flux like that left over from factory. Okay, so apart from that, which is interesting, visual inspection, nothing appears to have a hole in it. No chips with holes in them, no visibly burned resistors in the drive circuit that I can really make out at the moment. Okay, cool, cool, cool. Now, continuity of output FETs. That's okay, that's okay, that's okay, that's okay. So that side is alright. That's okay, that's okay, that's okay, that's okay. Interesting. So, the output section doesn't appear to be dead short. Now that's really the only time that the power supply will overload itself like that. When you have a big power supply overload like this, it's either because there's a dead short on the output side somewhere, or possibly that it's been reverse polaritied. That can also happen, but then also you'd usually get like bulged and vented power supply filter caps, which these are not. These look okay. The MCU will probably be dead in a reverse polarity event, I think, on these ones. So let's check the rectifiers. The rectifiers in these are known to die sometimes. So with rectifiers, there's no point reading between 1 and 3 because there'll always be a short there through the transformer. So we're just looking for any shorts between 1 and 2 and 2 and 3, which I'm not getting. So the rectifiers are not dead short. So what has caused this meltdown? Maybe a random power supply drive circuit fault or an MCU failure? Okay, well, the only way we're going to find out is just to strip all of the power supply and have a look at the waveforms and then go from there, I guess. You know what, I think it's actually just going to be quicker if I fire up the old massive soldering line and just bang these off in one go. What are your thoughts on sound quality between Class AB and Class D for mids and highs? So typically I would have always said mids and highs you want a Class AB. So Class Ds, the drawbacks to Class D is that you're essentially you're sampling. Okay, you're sampling the audio waveform, so it's not linear amplification. The audio comes in via the RCA, and then depending on what the Class D switching frequency is, that audio is being sampled at a specific sample rate. So that's a drawback. Secondly, Class D can have a much higher floor noise due to the remaining switching frequency and stuff going on in the output section with the inductors and stuff. So when you're running a Class D amplifier on specifically sensitive mids and highs, and specifically tweeters and bullet tweeters especially, you can get background hiss when there's nothing playing, and it's just nice to have dead silence. But really modern Class Ds and very well designed bespoke Class Ds are better sound quality wise than your average outdated and slightly cheaper built Class AB, for sure. It always used to be the case that Class AB was always way better for mids and highs and stuff than Class D, but that's not really the case anymore. There are many Class D amplifiers that absolutely blow out of the water most affordable Class ABs. So yeah, like, especially in an automotive environment, you're not really going to, provided there's no noise floor, you're not really going to notice the difference in a general kind of audio, a car audio setup between a decent Class D and a Class AB. So yeah, go with whatever fits your power requirements, budget requirements, etc. Stream time! Yes, yes, yes! Just for testing, I'm doing similar to your boomer bust. Okay, yeah, sure. I'll see if I can dig it out somewhere. Maybe send me a message on my Bevis Facebook page. South California, Ryan, how's it going, my friend? Good to see you here. Just a small question: is the PCB 2-layer or 3-layer? So basically, all of the most car amps that I come across are 2-layer. Don't really see many 3-layer car amps. There's a handful. Some of the JLs, some of the Alpines, some of the MTXs are 3-layer. But yeah, typically they all seem to be 2-layer. Oh, something interesting for your ass here. This has got so hot that all of the solder has disappeared, vaporized and vanished from the transformer. That's the transformer coming in there. Then all the solder's disappeared from there. So something was getting cooked, roasty toasty. I wonder whether we actually might have a shorted transformer. I don't know. I've not actually come across one of these transformers short yet. These are much less susceptible to vibration damage, this style of transformer, than the sort of regular toroidal one. But it could be, because we don't have any output side shorts or anything like that, so we could have a transformer short potentially. Sedonio, let's go! Let's go! Vamos! Right, is this cooked up enough yet? Let's see what we're doing. Let's see what's going on. This is a nice quick way to get these power supply FETs out. Heavy power supply damage without blown output devices. Exactly. What's going on with this? What's this all about? Unusual events be happening in the Bearvids workshop tonight. Strange happenings afoot. Like, power supplies don't just kill themselves, you know. Something happened. Something happened here. We're going to get to the bottom of it. Yeah, this is either a user error, like a reverse polarity. Could just be overcurrent, like, you know, in this case, in this exact build, in this exact amp with these exact parts, it could have been that the power supply FETs were the weakest link in the chain. Who knows? That's pretty uncommon though. You don't usually get that. But it doesn't look like this one's ever been repaired before. It's got all factory parts in it, with all the factory markings being scratched off, you know. So I don't think this isn't like, you know, a repair that's not been great or something. We need another chat fixes amp. No, we definitely don't need that. We definitely don't need that. Not after what happened last time. I was actually expecting that the video that I made from that live stream. So I did my live chat fixes an amp, and I thought that video, you know, the video that I've made from that stream would kind of take off a bit, but it never did. So I was a bit like, that's weird. I thought this video would do really well. Just while we're here, we're going to resolder the transformer pins here. Just while we're here, might as well, you know. In all honesty, there's a lot of videos that I've done that I thought, yeah, this video is going to take off, it's going to do really well, and it's flopped. And then there's videos that I've done just as a quick 5-minute thing that I just wanted to bang out there, not expecting them to do well, and they've hit like hundreds of thousands of views. It's very strange how that works. Do be like that sometimes. Oh, this could be a telltale sign. What are the gain settings like on the side of this thing? What do we reckon? Gain maxed out? No? Yes? Low pass filter turned all the way up? That's a bad job on these. Don't want that. These hate that. Even if you've got an active low pass filter on the head unit on DSP, you still need the low pass filter cranked all the way down on these things. They hate it, having it wide open, really. Especially like on subs. If you're playing full range, obviously you're going to need it wide open, but if you're playing on subs, they don't want it down low. Chat fixes an amp was really good. Yeah, maybe we'll do another one of those at some point. I need to, obviously in order for that to work, it needs to be an amp that I own, that's my amp, that we don't care about, that's not particularly valuable. Maybe I can schedule that in at some point. You guys need to tell me though, because obviously for that stream I need to get as many people on board as possible. So what's the best time for you? So obviously everyone that's here right now, obviously on a Sunday at whatever time it is in your country, seems to be okay. It seems to be a good time for you to watch this stream. But that's not the case for everyone. So I don't know. What do you reckon's a good time to stream? It's got to be a weekend, obviously. Probably Sunday. Sunday people tend to do less. I imagine, especially in the evening. You know, people aren't going out because it's Sunday, and people do working things on a Monday. So I suspect a Sunday would be the one. I'm pretty sure actually in my most recent live chat fixes an amp, I'm pretty sure that you guys did a fantastic job. I can't remember. I think it was just like a generic Chinese Class D type of thing, and I'm pretty sure that everyone did a really fantastic job, and I was quite surprised. So it's 8 PM here for me in the UK, 10 AM in Hawaii. Oh, I have a question. Hawaiian amps, I have a question. I sold a Digital Designs Z3 neodymium motor clone. It was one that me and one of my friends over here in the UK proven. He had this assembled. He basically built a clone of the DDZ3 motor. And someone in Hawaii bought it from me on eBay. I shipped it in really well packaged. Sadly, it was destroyed by customs looking for drugs. So when it arrived to the guy in Hawaii, the neo slugs were like not connected to the motor anymore. Naturally, he then put in a claim, and basically I had to give him a refund, and he kept the motor. So I lost the motor and the money. But I was trying to get hold of somebody in Hawaii or like around that area to, you know, accept the return of it, because I couldn't figure out how to get it back to the UK without costing me hundreds and hundreds of pounds in shipping, which was more than I paid to ship it out in the first place. So I was trying to find somebody in Hawaii that could like accept the return, so there was an address for him to send it to before I gave the refund, just so that, you know, I could somehow recoup some money from it somehow, or maybe even get it rebuilt over there. But if you come across any guy who has a completely destroyed DDZ Neo looking motor, let me know. I want to know what happened to it, because I'm a bit gutted about that, because it was a lot of money. I think it was like £800, which is like maybe about $1,000 or $1,200 or something like that I lost on that. I'd love to know what happened to it. I'm not going to get any money back from it now, obviously, but just kind of wondering if that's floating around, or if anyone's come across it or tried to repair it or anything like that. But if you see or hear anything of it, man, drop me a message in my Bare Vids chat on Facebook. We did good until Ian got a shot. Yes, he screwed things up, didn't he? For sure. That was very funny. Clifford Red, my man, how's it going? You say, if you use leaded or low temp solder, have you ever removed the power terminals? The Zupco AP amps are known for the terminals stripping out and are mighty expensive. Yeah, man, power terminals are pretty easy to remove. You just need to preheat the board with a big heat gun, like a 2000 watt hot air gun, big heat gun like a decorating one. So absolutely get the board really hot first. Then you want a nice big ass soldering iron like this, 200 watt if you can. And then yeah, just some 6040 solder. Doesn't have to be specifically low temperature, just you know, tin lead solder. Flood the terminal, and yeah, it'll come straight off. It will literally fall off on your desk. When doing terminals and stuff, just don't be scared about the heat. Like, so many people struggle with soldering, especially soldering big things, because they underestimate how much heat they got to put into this thing, and you got to put a lot of heat into stuff like that to get the solder to melt and for it to come off. Got to absolutely cook it. My motto when soldering always is high heat, low duration. You would have heard me say that before. High heat, low duration. You don't need the flux really so much when you are desoldering, and also, well, the reason you don't need flux is because when you're adding solder like this, it's going to be flux core. So yeah, you are adding flux by adding the solder. So you don't need any extra flux really, in my opinion, when you're desoldering big parts like that, because there's enough flux in the solder you're adding. But when you come to resolder it, yeah, sure, add some flux if you like. The pencil soldering iron you can get to boost up. Nice, I haven't ever used one like that, but that sounds pretty useful. Alright, well, I think that's all of the FETs out. So, with a failure like this, I suspect we probably do have a damaged driver, so we can investigate and see if that's the case. Let's just give this a little clean up while we're here. Yeah, these FETs went hot. These FETs went hot, hot. The thing goes skitty kit ba ba. We've got to remove them gate resistors as well still. Could you please fix my stepson? Why? What is not? No, I'm not a doctor. Still, I'm not a doctor. Can you fix my stepson? Make sure you clarify the differential between those two. Stepson 3K. If you are based in the United Kingdom, then yes. If you are not based in the United Kingdom, then no. So I'm just gotta get these gate resistors off. Now what I do to get these gates off is just put a bit of solder on the end of the iron tip like this, and then just kind of drag it over the gate resistor, and that has the effect of tinning the pads with fresh solder ready for your new gate resistor, and also taking this one off in a nice clean sweep. Rather than using the hot air, it's just really quick to do this. Especially these ones that have really got hot, sometimes the resistors like to kind of almost weld themselves to the pad. So now, which one of these two black ones is the gate? It's gonna be that one, isn't it? I don't want to remove the pull down resistor, unintentionally, but that one's gonna be the gate. There we go, lovely jubbly, lovely jubbly, pip pip. I'll tell you what I need. I'll tell you what I need. I need a more direct overhead camera. So you see the camera angle at the moment. You can't see what I'm doing because the transformer's in the way. It needs to be more like directly overhead. I feel like my old one of these back in the day, back in the old workshop, was a bit more directly overhead. Let me see if I can. Here we go. If I stretch that out a bit. There we go. That's a better solution. That's a bit better. That's more like directly overhead. Now you can kind of see what I'm doing a bit easier. There we go. Coming through with the solutions every time. If you have batteries in the back for your amplifiers, do you have to run a ground? You don't have to, no, because your vehicle chassis is the ground. However, different vehicles will have different resistances of the chassis ground from the back to the front. It's always a good idea, if you're putting in a really big setup, you might as well run a ground wire from the front to the back. Some people claim that it has made a big difference for them, so yeah, for sure. What you can do is you can actually see whether you'd benefit from that. You would need a multimeter with a really long wire on one of the probes, right? So what you'd want to do is you'd want to have a multimeter in the back near the amplifiers. You'd want to put your red probe, okay, on the ground wire going into your amp. So literally right by the amp, shove it into the ground wire going into the amp terminal. Then the black probe, you want to have that extended all the way right round to the front, to like the front battery terminal, ground terminal. So you want this one on the ground battery terminal, this one on the ground terminal of the amp. So obviously, the multimeter, put it on voltage mode, and the multimeter should show 0, okay, because obviously they're the same, they're both ground. But when you start playing the amplifier and cranking up the volume, have a look at the voltage on the multimeter, because it will tell you the voltage drop. The number on the screen will be how many volts you're dropping across the chassis, okay? And obviously if you see anything more than like 0.5 of a volt, well, that's like a reasonable amount of voltage drop across the chassis, so you might benefit from a ground run if you're seeing, you know, reasonable voltage drop. If it's like 0.1, 0.2, then probably not, you know, gonna see huge gains. But if you're above 0.5, definitely if you see a volt worth of voltage drop, then for sure a ground run would be beneficial. Cool, right. Boom, boom, boom. Let's shove some power wires in here now, I think. Just real quick as well, what I want to do is, with the multimeter on diode mode, just see whether we have any stanky looking numbers between ground and any of these gates. 760. How much better is the multimeter camera now, guys? Do you remember the multimeter camera would never freaking work? Well, since swapping it to one of these other Logitechs, it's solid. Yeah, these are all reading 760, so potentially the power supply driver might be okay, because we're getting constant equal readings between all of these, which is always good to see. Make sure that there's no solder bridges on the underside before we shove power to this. There we go. 12 and ground. The two most important things in life. How's it going, Mr. Sinewave02? Hope you're doing well, my friend. Hope you're crotch chilling back, relaxing, sipping on some apple juice, as we do. Apple juice is just absolutely OP. What an S tier drink. Like, a cold, fresh, sharp apple juice, you can't beat it, man. That is an S tier drink. Cup of tea, yes, as well, another S tier. Cup of tea. Apple juice with sparkling water. I can't say I've tried that combo yet, my friend, but it sounds like something I should try. Alright, power supply. Make sure we've got no idle current draw. My supply says that there's 0.1 amp. This because the ammeter's not calibrated properly inside, and I haven't got around to calibrating it yet. But when it says 0.1, there's actually no current draw there. Just kind of have to recalibrate your brain for that. So we are looking for, on the Descope screen, nice PWM. We're going to get health check pulses. So we're going to get very low duty cycle little sharp pulses to start with, like that. If I can, there we go. So see that? That's what we're looking for. So we're looking for 4 of these. So we've got 1, and the VRMS of that is 2.2. We're looking for 1 over here as well. Yep, that's looking good. And then over this side, yep, that's looking good. 2.3 and 2.3. Yeah, cool. So driver survived. I'm a driver, I'm a survivor, got on the bus and beat up the driver. Now we need some more gate resistors, some 10 ohms. Slap them in. There we go. We've got 1, 2, 3, 4, so we've got 3 MOSFETs per bank. So 6 FETs per transformer. 1, 2, 3. 1, 2, 3. And now we turn on the hot air gun. I came across 3 or 4 of those amplifiers in last year with shorter transformers. Touch wood, your man here has never come across one with a shorter transformer. Not yet. Seddon, that's not a thing, not that I'm aware of. We have Appletizer. There's a thing in the UK called Appletizer, which is like sparkling apple pop. I wouldn't necessarily call it juice, maybe like it's a pop, you know, like a soda type of drink, appetizer. It's pretty nice. Petite Mel, how's it going? Good to see you there, my friend. Nya, how's it going, Neko? I got some tea with honey. Usually isn't that a thing people have when they're feeling a bit rough? Like when I've been feeling a bit rough with a flu, cold, virus in the past, you know, I have like a lemon and honey drink, and that always hits the spot. Toby's got an amplifier that went into protector 0.8 ohms. It didn't smoke, it just won't come back on. So the Crescendo BC2 case, you're going to have dead output FETs. So if you're lucky, the drive circuit survived. So what I would do is, if you want to give it a go yourself, pull all of the output MOSFETs, get yourself an oscilloscope, have a look at what the drive looks like going to the gate pads of the low side. And then if it looks alright, then load up some new FETs and you might be lucky. Take a fresh cold Coke with a slice of lemon. Yeah, so I'm not a big fizzy drink person, yeah? So I don't really drink fizzy drinks. It's not really my daily thing. However, on a hot summer's day, like in the garden, really roasting hot, feeling a bit thirsty, sometimes ice cold Coke with a bit of lemon just absolutely hits the spot. But yeah, it's not a daily driver for me. I don't know if you see those memes that are like just literal cold water is just like god tier, a god tier elixir of life. Like water is just freaking awesome. Just water, literally. Get the temperature right. Just water hits the spot. So good. And what I find funny is that the water doesn't have a flavour, but the flavour of the water is the temperature. Does that make sense? So like the temperature of the water is the flavour. Now actually no, that's a lie. You do get different flavours of water, depending on whether you live in a hard water or a soft water area. Fortunately, I live in a very soft water area. The water is very soft, and that means that the kettle don't get no lime scale. And all of your appliances last a long time, like your washing machine and dishwasher. They all work more effectively as well with the soft water, so we're very lucky that I've got that where I live. Yeah, can't beat a bit of water. What is a ground loop? That is a bit beyond the premise of today's live stream, I'm afraid there, my friend. But if you want to understand why you might get alternator whine that you can't get rid of, I made a video on that. Just search Bear Vids alternator noise on YouTube and a video will pop right up explaining why you probably have alternator noise coming through your setup and how to fix it. Yes, cold water tastes pointy, yes, and yes, warm water tastes, yeah, I get what you mean. Warm water feels thicker, doesn't it? It feels thicker in your mouth, I think. Like, even though technically it's not, cold water is technically thicker, but warm water, yes, tastes round. I do get you, I do get you. I like, see, right, for me, I do like the taste of coffee. I will definitely love a nice coffee. The problem with me though is caffeine doesn't agree with me. Well, it's not that it doesn't agree with me, but I just don't like me on caffeine. I feel like my brain is already firing off at a million miles an hour on different things I want to do. Like I'm a little bit, you know, definitely ADHD going on here. And I feel like caffeine just kind of accelerates that far too much to the point where I can't really focus on anything and I can just feel my heart beating too much. And it's just uncomfortable and I just feel stressed. So yeah, I'm not really into the caffeine life, but I do love the taste of coffee. So I will have a coffee occasionally, but I'll have a coffee for the pleasurable experience rather than to get me going in the morning, for example. So many people are reliant on coffee and stuff to get them going on the day, and that's fine if you need that, but I feel like, I don't know, I feel like you can become dependent on it and you don't need it. Like if you're dependent on it, if you always have a coffee in the morning and then you suddenly stop, then yeah, you're gonna feel like, whoa, I am tired. But if you wean yourself off it, then you get to a point where you probably don't need it. Seddon says, I just repaired a big boy industrial coffee machine. See, that's probably what I need to be doing. That's where the money is at. That's probably where all the good money's at for repairing stuff. Because, you know, those things cost big coin. And companies will pay big coin to get them working again because they make them big coin. You know what I'm saying? So, like, that's where the money is. What do you think about 3-inch versus 4-inch coils for sound pressure? If the watts are the same? Well, there's back and forth, and you can't. It's very difficult. I personally quite like a 3-inch coil because there's more spider diameter, and although you do get more mechanical excursion limit, what you tend to find is with a 3-inch coil, the excursion will be the sort of the compliance of the spider will be linear for longer before it sort of starts to stretch out and introduce distortions. So if you've got a setup where the sub is required to move quite a lot and still sound good, then I prefer a 3-inch coil. But for pure air pressure and moving stuff, having the bigger diameter coil just does drive and have more of a grip on the cone. So for sound pressure, yeah, a 4-inch coil I would probably say good to go for. You also with a 4-inch coil you get a larger pole piece, which obviously will have a higher saturation point, so that's also good. Petite Mel says, I'm from France. I'm from France. How's it going? How is it in France? Boiled water makes a different sound to being poured compared to cold water. Yeah, it does, doesn't it? I'm trying to think. Although the thing is, you never really typically pour boiled water from anything other than a kettle. Like, you do sometimes. I'm going to have to test that now. I'm going to have to get some boiled water in a jug, pour it out into a mug, and then repeat with cold water in the same jug, and see if it sounds different. You know Roblox? Roblox? What the heck? Roblox. What is Roblox? Do you mean Roblox? No. I'm a bit old for that. Man's getting on a bit. Oh, it was on QI. Well, in that case, it's got to be true. I've got a 1600 watt sub hooked up on a 9K mono. Problem is, when I raise the volume, the voice coil is touching. I thought it was my sub. Change it, but it does the same with a different one. The voice coil is touching. You mean the voice coil is rubbing on the pole? So an amplifier won't cause that. If it genuinely is the voice coil rubbing, then just you got bad luck in that both of your subs are built off center and are misaligned. But a lot of the time I have found that sometimes when an amplifier clips, it will make a sound through the sub that sounds like sub mechanical noise. It sounds like coil slap. Sometimes when some amplifiers clip, they sound like, it can create a sound that sounds like the sub's bad. So it could just be that your amp is clipping. Why does the kettle get really loud and then quiet as it boils? That is not a question for me. That is a question for... there's like a few sciencey YouTubers that can probably figure that out. I suspect it's to do with the bubble size. So obviously when the kettle is first turned on, you have extreme heat on the heating element. Now that will create a lot of tiny bubbles, which you can see if you look at it. Then when it's fully boiling, the kind of bubbles are large, so the frequency is lower, therefore it sounds less loud. Possibly might be something to do with that. Aren't audio amplifiers a good business? No. Repairing car amplifiers is a terrible business. This is not a good business. what makes it a good business for me is that I enjoy it. So this doesn't feel like work. Like, this is not a lucrative business. Do not get into repairing amplifiers if you want to make big money. Nah. Nope. Now, if you want to get rich, don't repair amps. But if you enjoy it, then you can repair amps and never feel like you work a day in your life and make enough money to live somewhat comfortably. Thanks for the Sound Digital full bridge repair video. I've used that as a reference on a few amps. Nice! I'm really glad. I love comments like that. I love comments like that where, you know, I'm made aware that some video that I've put out has helped someone fix some amps. That's wicked. Glad to hear it, my friend. No problem at all. Cavitation, where the tiny bubbles that get instantly collapse again. So it was to do with tiny bubbles. I wasn't that far off. Nice. When's the next Boom or Bust? Not sure. I need to buy some things for Boom or Bust that are about a 7-hour round trip. So I'm just kind of waiting on being able to go and get those. Have you repaired a Macaroni amp? No. I've repaired Mosconi. Marsoni. I'm like, man's like macaroni cheese up here. Marsoni, no, I haven't. I haven't repaired a Marsoni amplifier. Not that I'm aware of, anyway. Is there a way that I could email you? So basically, facebook.com/bearvid, send me a message. I don't really... Oh, Mosconi, you do mean Mosconi. You do mean Mosconi. Yes, I've repaired lots and lots of Mosconi amplifiers before, yes. I have indeed. There's me like, oh yeah, that famous brand Marsoni. Do you want to? Like, maybe? I don't know. If you're based in the UK, then if you've got one that's dead, I'll fix it for you. But yes, I've fixed plenty of Mosconis before. So I'm just finding some 1404s. I might be a little bit low, actually, on 1404s. Let's see what we got. Hopefully I can find enough that are the same batch for this thing. So we've got 1, 2, 3, 4. That's a different batch there. Put those 4 there. Yes, I'm based in the UK, up in Durham, just south of Newcastle, where the sun don't shine. It does, but we get a lot of rain. Yeah, we be all up in the UK. Who else here is from the UK? Show of hands. Who is in the UK right now? What do you think about that big Stinger amp that old school stereo did a dyno run on? Don't think I've seen that video, so I can't comment on that just now. What's your favourite amplifier so far for subs? It's a bit of a hard question because there's many answers for that depending on the application. But honestly, I'll stick by what I always say, is that at the moment for a really big high power application, the Powerus board designs are looking like the best. For like, you know, for sort of 5K and above, the Powerus are pretty unbeatable in terms of, you know, what they've done with their circuit design. Just not too overly complicated, just really well tried and tested layouts and design choices. William, what is the meaning of life? The meaning of life is to live it. You just got to live it. Paris. It's spelt power, US, all one word. Man's a big fan of the Paris designs as a whole. What I will say is that they offer their amplifiers in 0.5, 1 ohm and 2 ohm variants. The 1 ohm variants are the sweet spot, I would generally say, for the bigger stuff. If you're going to get an amplifier from them which is 8K or above, get the 1 ohm version. If you are getting one of their like 2, 3, 5K amplifiers, then maybe the 2 ohm version, if you can obviously wire to that to accommodate for that, is the way to go. The reason I say that is because going for a 2 ohm version amplifier will mean that there's less current across the output section. The power is obviously the same, but there'll be less rail sag and less voltage drop because the current across the output section is lower. But the reason I don't recommend going for the 2 ohm versions in the bigger stuff is just because the rail voltages get really, really high, and they're not like super well optimized and designed PCBs for that much voltage across the rails. So I think the 1 ohm is the kind of sweet spot for the bigger stuff. Okay, I think that's all of the 1404s I have left. All these other ones are 1404s Z or Z if you're in a different part of the world. So let's see, do I have 12? Now we can, because we have 2 transformers, provided the specs of these are similar enough, we can actually run 1 batch on one transformer, 1 batch on the other transformer. That is perfectly fine, provided the VT and the CG is within tolerance. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 of one batch. So I've got 3.1 VT and a CG of 4.75, and that's on this batch right here. Let's just check another one for continuity. Come on. This is starting to die actually, this. I've had this for a long time. Okay, that's a bit different. So we've got 3.2 and a CG of 10. So let's do one more of this batch. 3.2 and a CG of 10. Okay, yeah, that's about the same. 3.3 and a CG of 10. So let's have a look at this batch. 1, 2, 3, 4, 5, 6. Uh, 3.1 and a CG of 10. So, okay, let's check another one. That's going to be close enough to the 3.2. Yeah, these are literally identical specs to the other batch. So, yeah, we can use these with no problems. One, 2, 3, 4. Six. Hi Sam from Iran, RTS. How's it going, my man? I don't think I've ever had anyone from Iran on the stream before, or at least they haven't said that they are from Iran. So how's it going? Good to see you here. Mr. Worldwide, it seems. Alright, let's get these soldered in. So, this is a bit of a mystery, this repair, for anyone that's recently joined. This amp, the power supply had a mega meltdown, big meltdown, absolutely cooked. We don't have any shorted output FETs, we don't have any shorted rectifiers, we don't have any shorted rail caps. So, this is either like an overcurrent across the output section because it was the weakest link in the chain, which I find hard to believe. That's usually not the case. Or it's a reverse polarity, but I don't think so because all of these capacitors in the power supply are not bulged. That you usually get a bulge on those because obviously they'll then be reverse polarity, which they don't like. So yeah, it's a bit of an odd one. The only way we're going to find out what happened here is to load up some FETs and see what it does, like see whether you know, it tries to kill the FETs again, or see whether there's any short somewhere on the output side that we can't see with the multimeter so far. It is a bit of a strange failure, this one. So I'm kind of curious to see what we find when we put some power. Now I remember why I moved my camera back. So yeah, the reason I didn't have my camera so overhead was because as soon as I lean in, you get look at that fucking nose, bro. Look at the nose, the triangle, the absolute nose cone. Bro, what is that fucking organ right there? The sniffer. Jeez. Got that strong Roman genes. That is a nose. You ever want to see a nose? There you go. That's a nose. My God. That's for sniffing out the opposition, that is. What a freaking unit! Now I can understand why everyone says I smell good. They don't mean I smell good, they mean I smell good. You know what I'm saying? I'll turn your hat around. Now see, if I turn my hat around, you're just gonna get hat brim. You're just gonna get the block. You're gonna get the Zelda badge. Cock block. Does a 5 watt resistor or a 3 watt resistor make a big difference? Yeah, about 2 watts. Depends on your application. If the circuit calls for a 5 watt resistor and you fit a 3 watt resistor, then it will run hotter than intended. But if you are fitting a 5 watt resistor in place of a 3 watt resistor, then you're good to go. No problems there. If you can fit it in, then it's fine. That's a good point. Yes, that's another potential failure. Explore, repair, restore. Copper strand could have took it down. Yes, that is a very valid point. That happens quite often, to be honest, especially in car audio. People stripping their cables right by the amp, right by the vents. Copper strand gets inside. Obviously, it causes a failure, then it fucks off, or it gets vaporized, so you never sort of see it was there. So that can definitely be a cause for failure. Yes, good shout. Good shout, sir. Have you ever thought at some point about designing your own amps? Yeah, man, I think about it all the time. The problem is designing your own amp is like probably a 3-year endeavor of solidly working on designing my own amp and making no money in the meantime. So it'll be something that I do when I feel a bit flush with the cash and I feel like I don't need to do so many repairs and I've got a lot of time on my hands. My man Tom bowling through with a 199. Thank you so much for the donation there, my friend. Appreciate you as always. Thank you very much. If you've got a question, something you want to say, give me a shout. Happy to help. But thanks for the sticker. So, in reply to Seddon's comment about the higher power resistors being more expensive, I would absolutely agree, yes. However, why do a lot of these Korean amplifiers have like 1 watt or 2 watt gate resistors? You see them. You see, if you repair car amps, you know what I'm talking about. A lot of these big Korean amps, they'll have absolutely massive, especially on the output side, big ass gate resistors. Like 1 or 2 watt gates. Absolutely unnecessary. unless I'm missing something and there's actually a benefit to having the big ass gate resistors that are passing like 0.00002 of an amp. Alright guys, place bets now. Place bets now. We power this up, and what's it gonna do? Are we gonna find a shorted transformer or something? Or is it just gonna work fine? In which case it was either a copper wire strand or like random failure. Random MOSFET failure can happen. Let's make a little poll. Let's make a little poll. Can we do it? Start poll. Started the poll. What happen now? Work good. Yes. No. No. Just no. An option. Darud Sandstrom. There we go. What's it gonna be? Josh is saying power but no sound. That would be unusual. It's not unusual to have power but no sound. Da-da-da-da-da-da. It's not unusual to have problems with your ground. Da-da-da-da. When the MOSFET's feeling like it's fucking around. Gotta get that flux up on and cook it up. Remove that shit, throw it in the bin. Do-do-do-do-do. My jazz vocation was lost with this, guys. My buddy had a datasheet explicitly specify wire wound resistors. The only reason I can think for that would be because it was making use of the inductance. Obviously a wire wound resistor is essentially like an inductor, right? It's going to have an inductance because it's a coil of wire. So I haven't come across a circuit or datasheet specify that they need wire wound, but I have come across with class AB amplifiers specify that they must not be wire wound resistors because when using for the emitter resistors, because the inductance of them can affect the frequency response, perhaps in some way. I don't think it would. I think the inductance is probably going to be too high or whatever, or too low. Yeah, I've not seen it requiring the wire round, but it must be because of the way that they behave at specific frequencies, perhaps, or yeah, maybe it filters the spikes on the audio waves if the MOSFETs are too quick. Yeah, possibly. They will definitely have some kind of inductance behavior. Any thoughts on the revamped US amps and the ever so controversial high slew rate and high dampening actually contributing to SQ? So I've always said for a long time now that those parameters are a spec from the past, and they made a difference in the past, in like the 70s, 80s, that kind of era, where you had extremely low extremely low magnetic force drive, like the motors on drivers were weak as heck, right? And the suspension systems were flappy around as heck. You had low power, and amplifiers of the time had very poor damping factor because the output devices, transistors or even tubes that were being used, had a really high output impedance. And that meant that the amplifier had very little like dampening braking force on the driver. Listen guys, listen. The way you need to think about this, if you don't understand what dampening factor is, this will sort your life out. Right, have you ever driven a manual car, a stick? Ever driven a stick? Ever driven a manual car? Even an automatic probably does this as well. Engine braking, right? So your engine is the amplifier, yeah? So you push on the gas, right? You're going. You're putting energy from the engine into that, and you're going. Now, when you lay off the gas, okay, now the momentum of the car, okay, the wheels are spinning, so now no gas is going into the engine. The engine is making no power. What's happening now is that the wheels on the road are turning the engine, okay? And that applies a braking force. That has friction. That slows the car down because you're spinning this great big engine that has friction and shit like that, right? So different engines will have different amounts of engine braking force, okay? A really tiny little, very well oiled, very efficient engine will have very little engine braking force because it doesn't take much energy to spin. So when you let off the gas, you're going to roll for a fair while because it's just going to be rolling along. And so that is a low dampening factor. That is an amplifier that has a high output impedance. The impedance or the resistance of the engine is high, so it doesn't really add much load to the vehicle while it's rolling. Now, if you got a big boss freaking race engine, right, with like some big ass pistons and like freaking all this going on, right, then as soon as you let off the gas, you're gonna be like chucked forward in your seat because that engine takes a lot of energy to rotate. Okay, as soon as you let off the gas, as soon as you remove power, that engine takes a lot of energy to rotate. That is a high dampening factor. Bigger amplifiers, modern amplifiers with high power output transistors, low RDS, will have a low output impedance. That means that when the voice coil moves in the magnetic gap, it creates electricity that is fed back to the amplifier. And the output impedance of the amplifier, if it's low, then that energy created by the voice coil moving in the magnetic gap will be dumped to ground fast, and the speaker will come to a stop quickly, just like your big engine with your very high engine braking force. But an older amplifier with very weak, with like high resistance, like, you know, older output transistors, and stuff like that, with a higher output impedance, the energy that speaker creates moving backwards and forwards isn't getting dumped to ground as fast because it's going into a higher resistance. Therefore, it rings for a little bit longer, the same way as your car will coast for a bit longer with an engine with less engine braking force. So that's how you should think about it. So in the modern world, with modern amplifiers, Class D, low RDS output transistors, all this jazz, and also with modern drivers having much stronger motors, therefore creating more back EMF to oppose, to dampen with, and also having much stiffer suspensions, just because they're less sensitive, the actual damping factor of the amplifier is already so high, and the dampening of the drivers, they're so critically dampened anyway, that actually the differences between one amp from another makes very little difference. And there are things online, there are documents online and reports online that go into this and explain why it doesn't really matter anymore. So I wouldn't buy an amplifier based on the damping factor or anything like that. Just buy it based on, if it's for subwoofer application, dynamic headroom is what you need. You need power, okay? That's the most important thing for a subwoofer application amplifier. Just buy the most power you can for the least money you can, because in subwoofer application all amps are going to sound pretty much the same. The frequencies are too low. Any of the slight tonal differences, characteristics of the sound, you know, the amplifier creates, so there's warm sound, fucking no. Low frequencies, 20 to 80 or 100 hertz, you're not going to fucking hear any difference. Subwoofers are crap, they don't produce, they're slow, they don't recreate any of these tonal differences between amplifiers anyway. So for subwoofer application, have as much power headroom as you can for as least money as you can. Provided the amplifier is reliable, you're going to have a great time. That is my piece on that. Have we soldered in all of these? Yes, we have. Somehow I've soldered all these bits in. Excellent. Right, fuck it. Let's put some power and see what happens. So we don't have any idle current draw. That's good. so there's nothing leaking to the gates or anything like that, causing any issues. So we're going to send the remote in, and we're going to get some pulses, and we're going to see if we build a little bit of rail voltage. Let's see. Let us see. So this is probably going to be high side. Okay, so as you can see on the scope here, every time I touch the remote, we're building a little bit of rail. That's cool, good to see. On the other side as well, we're probably going to rail. Yep, just have a look and see on the low side. So now we're on the low side drain. We've got 5.4 volts there. 5.2, yeah, is decreasing, that's fine. So that's equal on both sides as well. So we're just going to go for a full power up and see what happens, I guess. What's the poll? The poll says that we've got 63% saying that it's going to work good, yes. 16% say no, and 21% is... Well, I'm glad to see that they work good, yes. We have positive energy. We have positive energy in the stream this evening, and it's probably going to work. Let's see. Let's see if the positive energy is going to allow this to function straight away. We have to pump up the rail by keep pushing on the remote until the rail gets high enough the amplifier's happy to come on. Pump it up. Bit of eye protection, just why not? Okay, we're up at 70 volts. Usually that's enough, actually, for this to come on. What's he complaining about? Usually that's enough. Okay, let's have a little feel. Let's see if anything's getting warm over here. So, got a little bit of heat in these MOSFETs, actually. I don't know if that's because they're the last ones I soldered. Let's have a look and see what the pulses look like on this bank here. Okay, let's compare that to the other side. So that's what the pulses look like here. Ah! Oh, damn! Okay. This could... What's going on with my camera? Why is my camera frozen? Oh, that's not a flattering position. Okay, let me just fix the camera real quick. Can we fix the camera? Ah, OBS has crashed. Shit. Ah, there we go. We're back up and running, guys. Camera crashed for some reason. Very strange. So this might be the very first one of these that I've come across with a shorted transformer. That's gonna suck, because I don't think I've got a spare transformer for this. Hot damn! That is definitely looking like shorted transformer territory on the waveform there. But let's just, before we confirm, let's just have a look at the gate waveforms here. So, okay, gate waveform here. We know that the gates are okay, but that is absolutely looking like shorted transformer territory on the scope there. Yeah, look, we've got massive spike. 10, 20, 30, we're on a 40 volt spike up here. That's not good. It should be looking like this. That's what it should look like. Oh, man. Okay, so, I mean, you can rewind these. They're a pain in the arse. They're not as nice to rewind as the likes of the tutorial ones. Okay, well, let's remove it and see if we can like isolate the short quick and easy. You gotta dismantle the whole bloody thing though. I think that's one for another day. I want to kind of keep the ball rolling and just get stuff done and get stuff fixed. All right, let's just see whether it's like a nice, easy, simple short by seeing whether if I like grab and hold this, we can kind of make it change shape. No, not so far. Okay, let's just have a quick visual, because we might have like something shorting the the leads here. It might not actually be the transformer inside that's shorted. Could just have like a problem, something shorting these together. We've got a bit of glue there that can go conductive, but not so much that it would cause what we're seeing here. Yeah, I might remove it because that won't take too long. Then we can just have a quick look. Let's grab the multimeter and just see if we've got a short from the primary to the secondary, for example. Secondary will be here. So on this side, oh wait, hang on, oh, we've got the trial by, yeah, so we've got primaries here, secondary, we have secondary and ground. So obviously, right, so here. There's no short between the primary and secondary here or here. That's just ground, okay, that's fine. So on this one, okay, no short between primary and secondary either. So it's going to be probably a short between the secondaries or the primaries. Let's just end the poll for this. Randy, I'm not a battery guy. I would love to answer your question, but I'm not like super experienced in batteries, so that's not one for me, I'm afraid, buddy. Glad you like the old analogies there, my friend. I hooked up a Smart 3 to 16 volt charging system. Now the amp is in protector mode, come out, can it be fixed? Yeah man, you're just going to need some new output FETs. I can do that for you if you like. Also you could try clamp 2 wires on your LCR meter. Yeah, so the LCR meter will definitely tell us which one of those is shorted, but I'm going to remove it from the board because I just want to see if there's anything funky going on underneath, etc. Just make sure that there's no like DC on any of these pins. No, there's not. Okay, so which side was it? It was this side over here, wasn't it? So that's going to be this transformer over here. So let's get the big soldering iron turned on and let's just remove that and see what's going on. Then, I'm not going to rewind that or anything in this stream. Then we can look at, we've got maybe a Taramps Smart 5. So I've got 2 Taramps Smart 5s we can look at. Or I've got a couple of very similar circuits to this one that we just looked at, which are like the 4-channel version, like a 4-channel, 2-channel version. So let me know what you want to see, Smart 5 or a sort of multi-channel Class D thing like this. Matt just got in from work. We're working on a few different bits and pieces today, my friend. Your honest opinion on the Baseface Team Red stuff? So I haven't had hands-on experience with the drivers, so I can't really comment. But I definitely prefer the like the DB Audio Carnage, for example. That is a sick sub. That is like in the UK. That's probably one of the best like sort of big power, affordable subs on the market right now. Yeah, I want to see the Taramps. All right, we'll do the Taramps next. I want to see some proprietary Rockford amps. My man John, well, I'll tell you what. As soon as someone kills one and sends it in, then I'll let you know. But I can't magic out of thin air amps that are dead, that aren't dead. So I can only repair what's in the shop for repair. But next time I get something like that in the workshop though, I'll make a stream or make a video on it so you can see it, just for you. Wade, big up from Jamaica! Big man, what are you saying? Life in Jamaica, how's it going, my man? One of my favourite technicians. I'm a technician myself. Technicians, stand and rise. We keep the world turning. We keep the world turning, my friend. Thanks for jumping on the stream. I appreciate you. Hope you're doing well. Hope life's good out there in Jamaica right now. And keep up the good work. You're doing God's work, man. Love to see it. Are we hot enough yet? Which transformer was it even? Oh, it was the top one, wasn't it? Top one. This isn't going to be hot enough yet. I've only just turned it on. What we can do is we can preheat the board. Don't ever underestimate preheating the board. It makes a huge difference. Alright, now, provided this is all hot enough, if I can keep the solder melted on each of these pins the entire time, it might just fall out. Depends how well it's glued. So if I can just kind of cook this up, get this cooked up. Nah, do you know what? I think there's going to be too much thermal mass on the board here. What I'm going to have to do probably is just suck the solder out. Like that. What fetch would you go for to swap the 4242s? Yeah, definitely. They are well dead fets, out of stock, out of life. If you make some drive circuit modifications, you can get away with using IRFP 4868. They are some big beefy ass 300 volt fets, and you're going to need, probably to make some modifications, you're going to need lower value, well, you're going to need to put some 4148 diodes in parallel with the gate resistor to pull them down fast. They need to be turned off fast, those fets. So, oh man, this is going to be a pain in the ass, isn't it? This is going to be a pain in the ass to get out. What's going on, big man Leroy? How's it going, my friend? Good to see you here. Yeah, hard head. I saw that as well. Just here. This little solder bead just lives there now. I saw that as well. Actually, you know what? I think I could just hot air that transformer out without the soldering iron. Provided it's not glued in too hard, which I don't know if it will be. I might need to pry it. But I think we could just hot air that transformer out. Let's just shove something in there just to kind of act as a pry. If I just hot air this. Nah, it's getting a bit too hot for my liking. Those MOSFETs are like starting to fall out, so I'm gonna take it back to the iron. While the heat's still in there, let's get these sucked out. Yeah, the PSU FETs are like yeeting themselves out there. There's a lot of heat going on. That's what you want though. You want to not be don't be scared of the heat. Like, the board's fine. This isn't causing any damage or any harm or anything. I do believe though, this is probably going to be a bit of a pain in the butt to get out. Bit of flux? Nah, I don't know if it would. Maybe. The problem is the flux that I've got is very expensive and I don't want to just be wasting it on desoldering. Okay, we're making progress. Oh, big boy. Big boy resoldering my shit up in here. There we go. Alright, let's see if we can get these wiggled out and we can pull the whole thing off here. I'm sure I saw you with a Haku Vacuum. No, you haven't seen me with a Haku Vacuum. I would like a Haku Vacuum, but I won't pay the stupid price that they want for the 240 volt version. It's ridiculous. The 110 volt version of the Haku Vacuum is like £180. The 240 volt version is like £400. I ain't paying that. It's the same freaking product, just with a different heating element. Well, I've got to pay like over double the amount. Waste, man. So I would love one, but I'm not paying the price that they want for the UK plug version. It's ridiculous. Yeah, I get that it'd be worth a lot. It'd be worth it for, you know, the convenience, but it's just. I'm not paying that. Like, do you know what I mean? Oh, actually, no, you might be thinking of a different brand. I did have a desoldering gun at one point. It was just by a OUA brand, and it sucked. Well, obviously, that's what it's meant to do. But no, it wasn't very good. It didn't work very well. It just kept getting clogged up, and it took longer to use that than just using the manual pump. So, yeah, I'm a kind of manual pump guy all the way now, pretty much. This will come off. This will come off. We just gotta believe. There we go. So that's one side off. So now we've got to just grab it from here, and then we just got to wiggle the rest of it off. Now, it's very hot, so it's got to be a bit careful here. There we go. Told you to get it out. Yeah. I did actually just then accidentally break one of the leads here, but that's okay. It's just a tiny little lead. Just resolder that. So to see whether this is shorted, what I wanted to actually do is just have a little look underneath and just make sure there wasn't any like trapped wire or something that was causing that to be a problem. So what we can do with this now, we've got it out, is drop it on the LCR and just see what the guanin between the primary and the secondary. That's his ground center tap. So let's grab the LCR with a couple of wires. Selección. Can you see that? Not really. We're looking for this one. There we go. Let's get that up a little bit so you can see what it says. Can you? Why is that angle? The angle is just the worst. It's like dead straight flat. Get that so you can see it. Yeah, you can see it a bit better there. Alright, so between the two primaries, between the primary, across the primary, we are reading, just stay put for me, okay, so it's not picking up any, oh wait, here we go, it's, just let it settle. Okay, well, it's kind of all over the place, which is normal. Like these testers are not the best for reading like inductances and stuff. But the fact that I saw an inductance there is promising. So 624 nanohenries, and then we also did see a bigger number a minute ago. I'm just going to leave these wires on here for a minute and just kind of see if I can let it like settle. Ah, Sedden! I've got a DATS. I can just hook the DATS up. What a legend! What a great idea! Why didn't I think of that before? I've thought of that occasionally. You know, every time I've remembered. Oh yeah, the DATS can do bloody inductance readings. I've always been like, oh, I should use the DATS when I want to test an inductor, and I always forget. Use the DATS, obviously, and then I can show you on the screen with a screen grab. Right, let's plug that in. Have you ever done transformer or inductor rewinds? Yeah, all the time, all the time. Not my favourite thing to do, but yeah, I've done a lot of them. Right, inductor. This does not appear to be an inductor. Okay, so it could be the primary then, maybe. The thing is though, is that, the thing is that the DATS, right, is going to be sort of set up to, probably measure like crossover inductors, or like inductors that are designed to be operating in the kind of audio spectrum. This transformer obviously is operating above 25 kilohertz, above 20 kilohertz. So where it says this does not appear to be an inductor, well, it is doing something, up, like, you know, by the time we got to 20k, we were on the way up. So I don't know if the DATS actually is the best for this. Let me move over to the other, like the secondary here. Let's go between that side and the center tap, and let's see what we get here. Again, doesn't appear to be an inductor. Wait, is the resistance off the scale? Wait, what? Wait, the resistance is like above. Eh? What? All right, let me go across the outside one's inductor. Again, this one doesn't appear to be an inductor, but we got a big boost up at 20k. So yeah, I don't know if the DATS is the right tool for that. The output is not going through the DATS. Is it not? It is. Is it not? It definitely is. It only does. It can't not. Let me just get a quick test speaker to confirm. Here we go, a little test speaker. If this goes whoop, then we know that it is going out of this. Okay, come on, load. Yep. Yeah, it came out of the speaker, so yeah, the DATS is working fine. We do inductor. Speaker reads as an inductor. Yeah, see, it reads the speaker here as an inductor just fine. So the software and the DATS is working fine. I just don't think that it's going to work for the kind of frequencies that these transformers are going to be operating around. So we'll go back to our LCR. Good suggestion though, Seddon. We'll go back to our trusty LCR here. You can hear it on the stream very loud. I guess that's because OBS is probably pulling it through the stream. Apologies for that. Sorry if that's hurt anyone's system. Alright, so this is between the outputs. So we have we have 412 microhenries. Oh no, it's all over the place. It's really it's sort of struggling to pick up like a solid reading here for any of these, which it does. That's fine, but you know. Someone suggested to swap over the transformers. I could do, but it was quite a bit of work taking that transformer out. 2.9 microhenries. So let's go between here, the center tap. Okay, that's open circuit. Yeah, that's open circuit. And then between the two primaries, like, I'm not gonna lie, it kind of like, it's not giving me any obvious like, oh yeah, that's buggered. Okay, right. Well, visually, you can't really see much because of the tape and stuff, but let's just have a quick peek under here just in case there's anything hiding that's obvious. Not really. I'm just going to gently sort of tack it back in just on a couple of these holes, so that I can take a LCR reading of both transformers while they're in the board, see if there's any differences or variances, because that will tell us a bit more of the story. Like all of the wines on the transformer so far are giving us like a sort of Henry reading, so let's just kind of temporarily tack that back in with a very small amount of solder that will come off nice and easy. So I'm just going to put a tiny little bit of solder on each one of these, just so it kind of holds it in place and connects it to the rest of the circuit. So I can take some in-circuit measurements. Like this, yep, very tiny little bit of solder, that's all we need. That's all we need. Just holding it in place, just connecting it roughly to the circuit a little bit. Right, so now we're connected roughly back to the circuit. Let's just take our probes here and let's compare. So we've got the side that seems to be working fine. Let's go between the two. Let's go between the primary. So we should be seeing on the LCR. Oh, helps if I plug these in. You should be seeing. Okay, so an instant jump to 255 microhenries. 255, 254, and it stays there and it's not fluctuating around. Okay, let's go to the other side, see what we get. Okay, 244 280. It's very similar. It's moving around a bit though. It's moving around a lot more than the other side is. Someone says it could be the PIC, the MCU. I don't think so. So the readings on this one is definitely moving around a lot more than the other side. Let's just go back to the other side. The other side is literally locked in at 254 microhenries with a Q factor of about 32, 34, whereas this side is definitely a lot different. So my money here is on the primary being damaged, shorted internally. If we go across the secondary here, on the one that's bad, we have, let's let it settle. It's all over the place again. What about the good side? Right, the good side, we have 3 millihenries. With a Q factor of 10. On the bad side, we have like nothing, a low resistance. So yeah, okay, it's got to be the transformer. So we have removed the transformer and put it back in. So just real quick, provided there's no like solder bridges or anything, I'm just going to confirm that it still does the same behavior. Yeah, so it's still doing the same wave shape. Yeah, it's still doing the same wave shape. So yeah, it's definitely a transformer problem. You can see the difference in the output. Look, this is the good transformer secondary output. This is the bad transformer secondary output. So, damn! First dead transformer in one of these that I've seen. To see what we can source in terms of a replacement for that. Let's put this to one side and let's crack on with our Smart 5. Y'all want to see a Smart 5? You can see a Smart 5. Let's put these bits and pieces away from the screws and that. Oh, the pick comments wasn't for you. Sorry, I just dive in and out of live chat, and yeah, my bad. Donald says, your videos are like therapy to me. I find them so relaxing. I'm glad you're finding it relaxing. For me, I'm cooking. Well, I'm glad you find it relaxing. There are definitely some relaxing sounds that go on in the stream. Like, I quite like the sound of the scope. So if I turn the scope off, turn the printer off, that's a lot quieter. The scope has that kind of old 80s, 90s kind of computer desktop PC sound to the fans, doesn't it? Quite like it. This is in the way. Yeah, this is my multimeter camera. There's not much I can do about that. Let's just pop that up, pop that down there with the case. Right, so here we have Taramp's Smart 5 Team Hertz Addiction. Right, what's up with this then? Yeah, the scope sound is definitely iconic for like a Bearvid stream, isn't it? Like, it wouldn't be a Bearvid stream without it. Like, when I do eventually get a scope upgrade, the scope sounds won't be there, and that might hit different. You know what I'm saying? Mason, how can I send my amp to get fixed? Well, first thing you need to do is live in the United Kingdom. Bam, ba, bam. God save our gracious Queen. If you already live in the United Kingdom, then shoot me a message on facebook.com/bearvids. If you don't live in the UK, feels bad, man. But you'll have to seek out a technician in your own country. Yeah, I'm gonna have to do like I'm gonna have to record the scope sound as an audio file and just have that in OBS playing the entire time. You mentioned earlier not to have the low pass filter turned all the way up. Does it still apply if I use a DSP? Yes, it does, because having the low pass filter all the way up just unnecessarily allows potential for noise to be introduced into the signal path and not be filtered out. Like the low pass filter, that safety net needs to be there at the amplifier if the amp has it. So yes, the low pass filter needs to be all the way down on all of these full range like amps coming out of China, Brazil, etc. If it's a full range amp and you're using it for subwoofer application, low pass filter at minimum, and then also still use your DSP crossover as well. Stack them. Okay, so here we have a pretty clean looking Smart 5. Nothing immediately standing out. Now, how new is this? So I know that there's been a few different revisions of the Smart 5 over time. Is there a date? So this is 2021, July 2021. And this is one of the ones before they actually started putting anything under the inductors. So this is an earlier one. So they've since started putting stuff under the inductors here, because this rubs and shorts through to the PCB. That's been an issue on these. So I wonder whether that's the issue here on this one. And even if it's not, I think I might remove the inductors anyway and just isolate them, because this definitely does cause problems. With these. So why is this here in the workshop today? Do we have any dead outputs? If any of the inductors are going to be shorting through, my money's on this one, because this one has a wind that goes right on underneath the board. Okay, no dead outputs here. No dead outputs, no dead power supplies. So we fire it up and see what's happening. Just do a quick visual inspection, just have a quick look at the rest of the stuff going on here. A couple of buffers there underneath the glue. So one thing I don't like about these is the final drive buffers for the output FETs are miles away from the outputs. In perfect, in an ideal world, you'd have the final drivers for the FETs as close to the FETs as possible, especially for high and low side. These are a bit far away. Not the biggest fan of that. Yeah, here's these two on this side. They're pretty far away from the FETs. Not the biggest fan. Got the MCU, which is cool. Taramps are really good at supplying new ones of those if they fail. So, what's up with this? We're looking at a Taramps Smart 5, just me. So let's plug some power to this and see what's going on. Good evening, Lowry. How's it going, my friend? How do you feel about Kapton instead of mica pads? Depends, really. The thing I like about mica pads is you don't need to use the thermal paste. But Kapton is definitely thinner and has a better thermal transfer, provided the surfaces are pretty flat. So maybe Kapton. Was there no company literature? I'm pretty sure he did message me and tell me what was up with it, but I don't have my phone on me at the moment, so I'm unsure what the fault was. But we'll just power it up and see what it does. Right, power supply on, low voltage to start with. Let's build a little bit of rail. Let's put the scope back to auto level mode so we've got a trace there at all times. Power supply, little pulses, see if it builds a bit of rail. There we go, rail's getting built. We have output stuff here. So let's see whether we have any Class D switching. Okay, so we have Class D switching on both sides. I'm just going to give this transformer a little wiggle. Okay. Doesn't appear like this inductor, is shorting to the PCB just yet. Good job to this customer. Probably doesn't have this mounted to a sub box. So I don't think we need to do anything on that just yet. So we're up and running. Now we need to check for output and see why this might be here. I've got a feeling that this client said something about clipping or clip point. Maybe it was clipping early or something. Let's have a look at these controls on the side. The boost is not on, that's good. Low pass filter, why is the low pass filter on half? That's not what you want for these. The gain is on half as well, so we're going to turn the gain just down for a minute. So let's turn that back on, turn the signal generator on. Okay, got some signal going in, change the scope settings for audio waveforms, reject high frequency, power this bad boy up. Okay. Ah, interesting. So, just then, we had a sine wave almost to clipping, and then it went into protect. I'm not used to seeing that happen. All right, let's have a look at both sine waves and see what's going on here. Okay, so do we have an equal sine wave on both channels? AC couple. Let's have a look. So on this channel, hang on a minute, it just went into protect. Okay, so it's kind of tripping into protect. Now, what we're going to need to do is actually flip this over and have a look at what protection mode is tripping, because the LED sequence should tell us what the MCU is not happy about here. I'm actually going to turn the signal all the way down so we don't have any signal going in. I want to see if it still goes into protect. Okay, 1, 2. 1, 2. Okay, 2 flashes. There was no signal going in there at all. Let's just remove the RCA. Now this can be this can happen when the output inductor shorts to the PCB actually. It can just trip into protect like that. I was wiggling it around and it wasn't doing it. So I'm just going to do this again. We are only at 9.6 volts, but now that didn't come on at all. That just went straight to protect. Right, so it's going straight to protect at the moment. Now what I'm going to do is I'm just going to move both of these transformers, these inductors a little bit. Okay, now let's see if it comes on. Okay, it's not coming on. Now it's kind of just going straight, it kind of comes on, we get a bit of class D switching and then goes straight to protect. Interesting, okay. I don't really want to do this too much. I don't want to do this for too much longer, but I do just want to compare the waveforms for each side. Okay, no, so something definitely a bit unhappy there. Now, that could be inductor related, like shorting against the PCB, but I have been moving these around a bit and it doesn't seem to make a difference. Maybe, okay, what I'm going to do is I'm just going to hold these at an angle, and that should at least pull them off the board to prevent it doing that if it is in fact the inductor. Okay, no, so we're still, I don't think it's not really giving me inductor vibes. So let's have a look and remind ourselves, the manual, what does the manual say about two flashes? Let's have a look. Taramps, Smart 5, manual. And this will tell us what the MCU thinks is the problem. It doesn't necessarily mean that this is the problem, but it means this is going to tell us what part of the circuit it thinks is a problem, therefore that's why it's going into protect. Do we have an English? Yes, English, here we go. So 2 times flashing. Oh, battery voltage below 9.5. Okay, so that could just be my fault, so let's just increase that. I'm pretty sure these were fine down to 9, but let's increase it to like 10.5. Okay, so that's going to be well outside of the low voltage range. So let's power back up. And let's get our RCAs back on just to have a look at the sine wave again. Power it up. And the reason I always run the amps at like 9 point something first is because the output rail voltage is directly proportionate to the input battery voltage, and when you've got an amplifier being sent in for repair like this, you don't know what issues it might have. So having a lower rail voltage minimizes the amount of energy in the rail caps, so that means that if a fault does appear and something happens, having less voltage in the rail caps means there's less likely chance of huge damage to occur to the output section when the fault appears. So that's why I always run low voltage at first. But yeah, it seems like the MCU was a bit unhappy about that. 9.5 volts there. So we're going to go up to 10.5, and I've got the signal going back in, so we can just have a quick look and see what we're saying now. Let's just check class D switching again. It's going to stick at 10. There we go. It's going to stick at 10. Okay, so yeah, there's definitely no inductor shorts. So let's have a look at the sine wave then and see if it runs all the way up to clipping with no problems. Okay, there we go. So we hard clip on both sides just fine. There's no problems there at all. So I mean, at the moment this is looking like a fully functional amplifier. 12 volts, 14 volts. We've got a little bit of a wobble on the sine wave there. Above 14 volts, we've got a little bit of a wobble on the sine wave there. And that's possibly to do with power supply regulation. So where are we regulating on the power supply? Is it above 14? Yeah, as soon as we hit 14 volts, we're regulating on the power supply. And that seems to kind of be coming through the sine wave a little bit. I wonder whether that's audible on a sub. So I'm going to connect to sub and just see whether that's actually coming through there somehow. But yeah, so far, not seeing any problems. So I can't remember what the client said about this one. Let me just bring up my messages and see what he was saying was the problem. Let's have a look. Smart 5. So what are we sending? Da, da, da. Right, in the Smart 5K's box, vibration damage on 2 of the 5.4s and the 5K possible power supply. Not getting anything that was mentioned about why the Smart 5s are being sent in. It might have actually been just to look to see what differences there were between the 2 different Smart 5s. Are you going to do a video on the differences between the old and the new Smart 5K? The old one gives more power when it works, bought in 2023, one of the first ones in the country, and the new one was bought end of last year. Okay, so maybe these were just to kind of look at the differences between the circuits. Right, so this is one that's dated on the board 2021. So let's grab the other Smart 5, which I've got just here. Okay, let's just pop this one here. Let's just have a look and see if the board looks any different and see if this one's got a fault, because he did say when it works. So that leads me to believe that at least one of these has got a problem. Why did you choose an analog scope against a digital one? This is a digital scope. It just looks like an analog one because it has a CRT display. But yeah, this is a digital scope. I don't specifically choose a scope for a reason. This is just the first oscilloscope that I ever purchased many years ago, and it does the job. So I've never needed to buy a new one. I would like an upgrade. I'd like a color screen. I'd like a bigger screen. But I've just never needed to change it, so I just haven't. The only reason I bought this specific model was because it just so happened to be on Facebook Marketplace nearby to where I was living. So I just went and grabbed it. You know, there wasn't any real reason I got this model. Right, so this is what I was telling you. This is what I was telling you guys about the output inductors. Look here. So this is 2023. So here we have a 2021 and a 2023. This is actually pretty interesting. We can really see some differences here between these two. So the 2021 model, there's something in this amp. There's something floating around here in behind the PCB. I can hear it. It seems to have stopped now. Maybe that's got something to do with why this one doesn't work. Anyway, you can see here that on this one, we have some kind of little cardboard underneath the output inductors. Now, I said to Taramps originally, there needs to be something under the inductors. So I'm really glad to see that they did that. And that solved a lot of the issues with the, that's a bit loose, isn't it? That's not great. But that solved a lot of the issues with the inductors rubbing through to the PCB. See here? Whereas the 2021 built PCB does not have that. Like, stupid. It's just sitting on the board. So what other differences can we see? Right, let's put these side to side. It doesn't really look like the layout has changed at all, really. My camera can't zoom out enough for you to see the different, you know, both in the same shot, but let me just, alright, let's just have a look. So everything's in kind of, let's have a look at the output sections. So the actual PCB got that sniffer coming in again, smelling out them differences. But yeah, the PCB appears to be exactly the same so far. Not seeing any differences anywhere. So the only difference we've seen so far is that there is cardboard underneath the output inductors. Now he did mention something about making more power, so I wonder whether there's a difference in rail voltage, which we can check. We can have a look and see that. These are both Smart 5s. They're not Smart 5 bases. They're both your regular standard Smart 5. There is a difference in the PCB just over here. You can see this PCB has a little solder kind of resistor that gets fitted to tell the teraamps whether this is a Smart 5 or Smart 5 base, whereas this one doesn't have that. So that's one PCB difference that I've seen, but I think that's the only PCB difference that I can really see between these two so far. Everything else looks to be the same. Nothing has been added or taken away. Uh, 4127s. They've removed the MOSFET model marking. I guess that they started using different parts in the output side. So they removed the marking of the output MOSFETs here. Let's see if they are using different FETs. So in the 2021 version, they were using the 4127s. What are they using in this version, in the 2023 one? Well, they're still using 4127s, so the same output MOSFETs. Extra traces on the FETs. From the top of the PCB, doesn't look like it. No, it looks the same to me. Alright, let's take some electrical measurements. In terms of power, there may be a difference in the rail voltage if there's a difference in power. So let's have a look and see what the maximum rail voltage tops out at on this one. The older version here. So power supply back on. Let's have a look. Okay, so we start regulating. We're right up at 189 volts. So yeah, 189 volts is the power supply regulation, 190 thereabouts. So that's where the older Smart 5 regulates at. So let's plug the new one in and let's have a look and see whether that's the same or lower. They may have lowered it a little bit for reliability. 190 volts is quite close to the breakdown limit of some of these parts here. It's not the worst that I've seen. I've seen some amps run the rails at like 198 when all the parts break down at 200, so it's not the worst. So let's plug this one in, and I think this one doesn't work, does it? I think he said that this one failed, so I might not actually be able to power this one up just yet. Might need to do a repair. Let's have a look at the output FETs. I'm pretty sure there was something floating around inside. Okay, no dead outputs. Okay, so no dead FETs on this one. Let me just this one seemed to have something like inside. I could hear something rattling a bit. Oh yeah, I can hear it. There's something in this one. So what I'm going to do is just take one of the side plates off and see what falls out. Hopefully it's just a bit of plastic or something. let's see what falls out. Okay, it was just a piece of plastic. No worries. That's good, because that means it hasn't shorted anything. So we don't have any dead FETs. So let's just plug this in and see if this has any problems. I can't imagine he would have sent 2 working Smart 5s in just for analysis. I would have thought at least one of these is going to be dead. So we're going to start off, we're not going to go 9.5 because we know that that's the voltage he doesn't like. So we're going to go 9.8 and just have a look, see if it makes rail. Okay, yep, we're at 120. Yep, there we go. So let's just, the fans sound different on this one actually. So let's just probe the output here. Put this on here. Okay, so we have Class D switching, so that's a good sign. So both of these seem to sort of be working. So let's just wiggle the inductors, make sure that's alright. Yeah, it's good. So let's see what the rail voltage is of this new one. Whoa! Sheesh kebab! This one is off the scale. Uh-oh, that one's like, oh. What? Nani? Okay, this one is regulating too damn high. That is not good. The limit on these components is 200 volts. So, either, what are the capacitors in this? These are 200 volt caps, and we were above 200 volts there. The MOSFETs are 200 volts. The drivers are 200 volts. So, okay, what we need to look at is this has either just got a problem with the voltage divider resistors for the MCU, or they've changed the value of them and made the rail be higher. Does this regulate? Hang on, I don't really want to do that a lot, but I just want to see, does this actually start to regulate the power supply at all above that point? Let's just turn this back on again. Right, so this is unregulated so far. No, it's not regulating it at all, is it? Look. Whoa! It's not regulating. Right, so either something is wrong with this, it's not regulating the power supply and holding the rail at 200 volts like it should. I mean, it's not got a problem currently. There's no current problem with this, but that is not good. This is not going to last long at all. So we need to solve that. So I just want to have a quick look at the resistors that are responsible for creating the voltage divider so that the MCU can see what the rail voltage is. It's possible that the resistors have gone out of tolerance or something. So I'll just let's have a look. The rail voltage is here. We're still miles high in the sky, of course. We're still at 140 volts rail. So we're looking for some very, very high value resistors that will have those kind of voltages on them. Somewhere around here probably, if all is well. Can't remember where they are on the Smart 5. This one here, no. This one here, no. Here maybe? 76. No, so it's not quite there either. Oh no, they're here. Yeah, here it is. Right, so it's these two resistors, so R29 and R19, stepping the voltage down, then into R33, by the looks of things, and then into the MCU, and then we also go to ground via this, possibly here. There we go. So 24 volts. $93. So yeah, that's your rail. Stepping it down through these two, over here, R33. And on the other side of R33 we have 1.1 volts for the MCU. Okay, so let's just see whether those resistors are the same values in this one that is regulating correctly. So in this one we have a 2402. I don't think I'll be able to zoom in enough for you to really see this, but you just have to take my word for it. So we've got a 2402, and in this one we got a 20. This is a different value. 2322. 2402. And then we have an 1802 and a 2202. So the resistors are different. So why in the newer one did they decide to deregulate the power supply so hard like that? I'm confused. Why would you do that? And then we've got a 1432 there. So that resistor is the same, but the two resistors in the middle here are different. So the newer one will make more power because the rails are higher. But that doesn't make sense because I told them, like in my video I was like, yo, the rails are too high. So they went and made them higher. Why? Why would you do that, bro? Okay, well we're going to have to fit some resistors there to regulate that a bit nicer, hey? I think that we can't be having the rails like exceeding 200 volts. Use the amp ground as a reference. Newsflash, in these Taramps amplifiers, both power supply and amplifier grounds are common. So I'm using the correct ground, trust me. So yeah, crazy. No fault though. Like, it's working fine. So we just have different resistor values. I'm going to ask them about that. I'm going to say, hey, why did you do that? This seems to be making it less reliable. No comprende. So if I just wait for the rail voltage to sink down, we can actually drop the multimeter across and see what the resistance is total. So I'll just grab a resistor and just pass this through to ground real quick. Okay. Yep, that's grounded. Let's do the same on this one. So just going to ground the rails, so empty the rail caps. So with the multimeter on the older 2021 built, the voltage divider here reads as, let's just wait, it will climb a little bit because it's got some capacitors that are charging, so let's just let it climb a little bit. well, that can't be right. It's not above 20 mega ohms, for God's sake. Yeah, I must not be able to read it in circuit because there's too high of a resistance. Yeah, no, I can't read it in circuit. The resistance is too high. What a shame. But yeah, crazy. Let's just add these resistors up. We have two on this older one. We have 2402, so that is 24000 plus, so a 24k plus an 18. So we have 42 kilo ohms there. Which doesn't seem like that much. And then, but then we go through a 1432. Okay. Whereas, so that's 42 kilo ohms on the newer one that doesn't seem to regulate the power supply properly. We have 2, 3, 2, 3. Plus yeah, that makes sense. It's a higher resistance. It's 45 kilo ohms as opposed to 42. So that will regulate the rail at a higher level. So it's intentional. Like the rail will still be regulated, but it looks like it's going to be regulated above 200 volts. Wild. Why would they decide to do that? But yeah, interesting. So no faults with these, but I'm just going to have a play around. I'm going to change the resistance of the voltage divider on this newer one to actually bring the rail down, because I don't like it. Differences in the MCU specs. Nah. The MCUs are the same. I mean, they can change the programming, obviously, to set a different threshold, but they've changed the resistors, so there was obviously an intention there to increase the rail voltage with higher voltage resistors. It just seems really strange why you'd choose to do that on an amplifier that already has rails that are like mega close to the voltage breakdown limit. Right, let's have a quick look at these little 500 times 4s. These are, again, like a Chinese Brazilian clone type of thing. These ones, the customer said he thinks there'll be some vibration damage going on with these. So let's have a little peek, see what we got. Okay, right, no fiery smoke, that's good. Now these amplifiers all have a manufacturing issue. See, the inductors here are held down by this adhesive. Well, unfortunately this adhesive has a side effect of corroding the solder that they use. So this adhesive here, it corrodes the solder for this diode. Yep, there we go. This is exactly what's happened on this one. This diode is not soldered to the board. I don't know if you can see it moving there. I might need a different tool here. But this diode is not soldered properly to the PCB. Yep, see, it's moved itself off the pad. See that? There you go. So the adhesive here just like absolutely breaks down this solder, and therefore it throws the amp into protect. Sometimes it kills the FETs, sometimes it kills the power supply as well. So let's just see, did he get lucky and it hasn't killed the FETs on this one? Hello, technical specialist. Okay. Lucky, no dead FETs on the one that has the diode problem. Lucky. Uh-oh. We do, though. We do seem to have dead MOSFETs over here on a different, completely unrelated channel. So we need to resolder this diode anyway, but seems like, yeah, we've got some dead FETs over on this side. This one here appears to be toast. David, how's it going there, my friend? Good to see you on the stream. Good to see ya. Good to see ya. I think I'm going to go to bed. Good night. Good night. Singrin, thanks for jumping on. I appreciate you being here as always. This is Dave from Louisville. How's it going? Good to see you. Ah, ex-Rockford Tech. Nice. Very nice work there, my friend. Okay, diode soldered back in, and we have a toasted H8 MOSFET. This appears to be this one here with the low resistance across it, so let's cut that out. Cut the gate off first to confirm. We do in fact, yep, have a dead FET there. And how's the one next to it looking? Also dead, no worries. 429. So while we're doing these nice easy boards, I'll do a little bit of Q&A. Why don't we do a little bit of Q&A? I've actually just noticed I can start Q&A. Hey yo, what you saying? Why is that so broken? Why does that look so broken? Question. What? Select questions. There we go. Questions. Start a little bit of Q&A. See what that's all about. I've never done that before, so just going to see what that does. See how that works. seems to have got rid of my main live chat though. What is your favorite color? Favorite color would be green. The reason I like green as my favorite color is because it's a very positive color. It signifies positivity and lusciousness and nature and health and go. Green is like a very positive kind of vibes color, so I'm all about green. I also like the color yellow for similar reasons. Yellow is a very like energetic color, and I'm a pretty energetic guy, so that works. A bit random, but have you noticed the effects of Brexit in your repair business? I mean, there definitely probably have been some effects, but not that I've specifically noticed. The only thing that I now can't do is I did used to take work from Europe. I used to take some work from B2 Audio, and I would take some work from European-based clients if they needed to send stuff in. And the shipping was like nice and cheap and stuff, and I could order parts from, you know, European distributors and stuff. Whereas now, can't really do that. So yes, I guess I have noticed the effects in a negative way. Just for reference, I was a Remain. I voted Remain. Yeah, but it is what it is. I've got an old amp with some bad MOSFETs. Is it recommended to replace them all with the same, or just replace a couple? Green, yeah, green's good. So it depends on what section they're in. So if you've got a multi-channel amplifier with MOSFETs in the Class D section, or even in the Class AB section, actually, you can have MOSFETs in Class AB. If you've got some bad MOSFETs in one of the channels, then you need to replace all of the MOSFETs in that specific channel, but you don't need to replace all the FETs in the other channels. If you've got an amplifier that's a mono Class D amplifier, and you've got some bad FETs, then yes, you need to change all the FETs. And if you've got bad MOSFETs in the power supply, then yes, you need to change all the FETs. So the only time when you can get away with not replacing all of the FETs is if you have a multi-channel amplifier and one channel's gone down but the other channels are okay. That also extends to a full bridge mono amplifier. So if you've got a full bridge amplifier that's set up as in a mono or format, then essentially that's actually a two-channel amplifier. So if you've just got dead MOSFETs on one of the channels, one side of the full bridge amplifier, then you can get away with just replacing the MOSFETs on that one side. However, one thing to bear in mind is that the amplifier may have failed because the output MOSFETs as a whole were stressed due to some kind of shorted speaker or some drive circuit fault, something like that. So even if one side of MOSFETs survived, doesn't mean that they weren't internally weakened or damaged, or they might not have much life left in them. So seeing as you're there anyway and you're replacing some of the FETs, you might as well just replace all of them for peace of mind. I have several Sound Digital Evo X20K in my car. Would you swap them for Korean half-bridge amps? No, I wouldn't. I'm not the biggest fan of the Sound Digital circuit, but I definitely prefer them to the old Korean circuits. So I would probably stick with your Sound Digital for now. If you were going to swap them out, the only brand that I would swap them to is Power US, however you want to say it. They're my favourite high power subwoofer amplifier circuit at the moment, but the biggest they make is a 15K, but it is 15K at 12 volts, so it'll make about 19.5K I think at 14.4, and they're very stout. There's not a sound difference between amps, but they just feel very powerful. I've had some friends over here in the UK switch from Power US amplifiers to very similar powered Taramps MD12Ks, and the MD12Ks, although the rated power was very similar or possibly even more, it didn't seem to just have the same guts to the sound as the Powerus did, like in terms of power. So maybe there's a bit more rail sag with the Taramps, but the Powerus are definitely very stout, very strong sounding powerhouses. Could I get away with eliminating the fan on a Powerus 8K? Oh, if you're only going to be running 3K, then yeah, definitely. Yeah, definitely. I'm pretty sure that they have thermal protection anyway. So yeah, if things get too hot, the only thing, the fan isn't helping to cool the MOSFETs and stuff really. So the MOSFETs are cooled through the heatsink, and the heat dissipates from the outside of the case to the outside world. What the fan is doing is it's cooling the internal components like the inductors, the transformers, and all the drive circuit and stuff like that. But if you're not doing big power, then you can maybe get away with removing the fan. The output inductors can get hot on the Powerus amps, as my good friend Donnell in the Sinewave 02 has discovered, but I think you'll be fine. I watched a video from you and Williston Audio Labs talking about Smart 3. It was noted that the gain knob's lowest or highest setting is 4 volts. My DSP outputs 5 volts. So your DSP doesn't output 5 volts at all times. What that means is your DSP has the ability to output 5 volts at its maximum output. So your DSP will only output 5 volts when it's being told to, okay? So when, you know, the DSP levels are cranked up and when the input voltage to the DSP from the head unit signal is cranked up, so your DSP is not going to be outputting 5 volts. So provided you keep your, you know, DSP levels sensible and you're not pushing them to the max, and providing you're not pushing your head unit to the max, your DSP is not going to be putting 5 volts. So the voltage to the amp is going to be perfectly fine. Alright, that should be good to go now with this one. That should just work now, provided there's no drive circuit damage. We could have killed a driver on that side with the dead FETs, but I doubt it. Let's just see. Ground in there, 12 volts in there. I'm actually not even going to screw these in, I'm just going to hold them in with my hand. Let's go 9.6. Okay, let's check for DC offset. So we have do we have a dead rectifier? I think we do. This does happen in these actually quite often. 90. I've got a feeling this rectifier S2 is dead. Because we're getting a bit of DC there. We're getting some low values as well on this rectifier here. Negative, 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 negative. Yep, I do believe that that rectifier might be dead. Chris says, why? Because. You mentioned once that an amplifier power supply could literally run independently, although it's dangerous because of the voltages, but it's, if someone tried, how many peak DC amps versus RMS, wait, what? But someone tried how many peak DC amps versus RMS amps could a 3K? Not sure I understand your question there. Is it better to have higher voltage going into the amplifier than a lower one, or does it not matter? Well, higher voltage will typically create more power because the rails on the output side are directly proportionate to the input voltage. So yeah, if you're trying to get the most power out of your amp, then higher voltage is better. But in terms of actually what the amplifier is happy doing and idling at, lower input voltages are actually better health-wise for the amp because everything inside is running at a lower pressure or lower voltage, so it's under less stress. So in terms of just using the amp, provided you're not at the amplifier's clip limit, then lower voltage should technically make the amplifier last longer. Let's just come out of this Q&A for a minute. Let's just go back to the live chat. Yeah, I'm going to exit this Q&A. It doesn't actually seem to be that you can just do Q&A in the main chat. What changes are made to an amplifier to determine 0.5 stability or not? It's just the amount of current that all the components can handle. So you've got power supply FETs, transformers, rectifiers, output FETs, inductors. The H8, I think, might be a... I think it might be a 4115. Yeah, I think it's a 4115 or equivalent. Okay, so that rectifier's out now. We were seeing some low resistances between 1 and 2 and 2 and 3. We still have that. Okay. So something else is not happy. The rectifier's okay. Maybe we have... Do we have a dead driver? But then we also see that low resistance. Oh, sorry, we also see the DC on the other channels too. Let's check some of these drive buffers here. These AGQ and DK. Okay, no short there. What about, so we've got a low resistance here, 83. I think the driver's toast. Okay, let's remove the driver. This would be a 2092. You're the reason I bought the 15K Powerus after your review. I honestly think that I am responsible for a lot of Powerus's success and a lot of their sales. Good night, RTS. Hope you sleep well, my friend. Oh, I reached the text limit on my question. Okay, no worries. What's the diode that had the corroded solder used for the circuit? It is the bootstrap diode that acts as the pump. So it has the low side class D switching on one side, and on the other side it has a capacitor to ground. So sorry, yeah, it has a capacitor in series, and then there's a capacitor to ground, and it basically creates 15 volts worth of high side supply that uses the low side switching as the ground reference. So it works like a pump. Jadine says, how are you switching OBS scenes without touching your hands? Foot pedal, yeah, I've got basically under the desk, I'll show you, I've got 3 foot pedals that I use to switch the scenes. I've got another foot pedal here which is for the remote. So this foot pedal turns the remote wire on for the amp, so I can turn the remote on with my foot. And then I've got these foot pedals for switching scenes, and I also have this LPD8, which I also use for some additional scenes. So I've got the hat cam, which is this one you're currently looking at. I've got a screen view, and I've also got some sound effects that I never use. I literally never use these. I should, are they even, oh, it's not even connected. So of course they weren't working. Wait, let me show you. Let me show you. Let me just close this. I have to go MIDI to key, start, right. I never use these, I always forget that they're here. So I would use those if I remembered, but I don't, because I always forget. But that's how I switch the scenes with the no hands. Leroy says, I must confess I learn a lot from you and I'm still learning. Oh, I'm glad to hear it. That's literally the only reason I make these videos, is so people can learn, man. So if you're learning, that's cool. That's cool. I'm happy. Happy? Learning? Learning happy? Good? Good. Man, I freaking love the In-Phase XT line. What an amazing sub for the money. It absolutely takes abuse like so good. It's so affordable. It takes so much crap. And it sounds pretty cool as well. They're just great little subs, man. Absolutely love the XT line. What a great little sub. What thermal paste are you using? Literally just the cheapest bulk stuff, because that's what they use from factory, and it's the way that these amps generate heat is not so critical for the type of thermal paste you use. It's not like a computer CPU or anything like that, where it's like a sudden, extreme, immediate amount of heat from a very tiny area. That's kind of not how the heat's generated in these. So the thermal transfer quality of the thermal paste is less important on these. Also, you use a lot of it. I go through a lot of thermal paste, so I can't afford to be buying some next expensive CPU thermal paste. So I just use just some bulk stuff, the same as what they use from factory. Two times 1,000 watts into 8 ohms? No, I don't know of a car amp that will do that. Lots of PA amplifiers that will do that, but I don't know of a car amp that will do that. Working on a new variant, let's just say it won't be stamped anymore. Well, the only thing I would say is that the XT, with the motor and everything, it's fine. The stamped basket is fine. So if a cast basket will drive up the cost to the end user, to the customers, if they're going to be more expensive because they got a cast basket, I would say don't bother, because the stamped is fine for this level of sub, and the cast won't actually give any benefits or any drastic performance improvements over the stamped. So keep put the extra money somewhere else, I'd say. Doesn't, like, yeah, the cast will look better, but in terms of its performance and what this sub is trying to do, it doesn't need the cast basket, in my opinion. But if it's not going to be any more expensive, then for sure. Sounds good. Okay. No, the low resistance is kind of still there still. Alright, there's something else. Maybe there's another FET that's bad. Alright, let's go along all of these. Maybe there's another FET that's kind of gone bad, but hasn't gone to dead short. Huh. None of these. So where is this low resistance that we're seeing? 125. And then this one. It's higher than it was. I'm wondering, like, whether there's multiple drive ICs failed here. That can happen. Right, sometimes if one of the drive ICs fails, it can send a voltage or a spike through its VCC supply, and it can kill a lot of other drivers as well, even on channels that are fine. Oh, it'll be a new lineup. There will still be the OGs. Oh, okay, cool, yeah. If they're being released in parallel, that's great. So Seraphim, that is just noise floor because it's a Class D. So there's no fix for that as such. You can try putting some film capacitors across the output terminals, might help a little bit, but the only solution is to get a better amplifier that's got a better designed filter network, or go Class AB. Okay, well that low resistance has gone away now. So yeah, both of those drivers were not happy. Weird. Okay, let's power it up and see whether we get Class D switching on the remaining channels now. See if there's any DC leakage from any of the other channels. So that is just like I said. You can have one channel that dies, kills the driver, and then that driver being killed can actually spike back and kill other drivers for other channels, even if the FETs are fine. So let's just get this connected up properly. Okay, so I'm not going to power it up fully. I'm just going to pulse the remote a couple of times just to build a little bit of rail voltage, just to make sure that all the DC is where it's supposed to be. So, okay, cool. So we have negative 40 there, and we should have positive rail somewhere as well. Where the heck is the positive rail? Donde? Where is the positive rail? Where is the positive rail gone, bro? Maybe one of the rectifiers is actually bad. Positive rail should be here, I think. Yeah, something is funky here. Something funky. I think I'm going to remove both of these rectifiers actually, put them in the tester, and also see what the incoming AC from the transformers looks like, because we're only getting negative rail. I'm not used to seeing that. It's very strange. Ah, hang on a minute. This is a common fault. We're missing this 470. Right, this is a common problem on these. There's a resistor here that couples the output side ground with the main side ground through a 47 ohm resistor. That is open for us, okay? So, let's replace that, and I suspect that things will start looking like they should do on the oscilloscope. Because we don't have any output side shorts from the positive rail to ground, so there's no reason why we shouldn't have positive rail. So I think this has just been cooked. It looks fine though visually, but you know, weird. So let's drop a new 47 in there. Definitely got some 47s in the big enough size somewhere. Where the heck are they? Greater than 10. Yeah, it should be in here. A 100, 22, 100. 15, 10, 1,000. Right, here we go. Here's some 47s. Not quite the right size, but they'll do. Don't use hot glue in amplifiers. No. Bad. Can I use a regular silicone for in the bedroom to put over the resistor? Right. Do not use hot glue in an amplifier. Hot glue has no place in electronics. Stop using hot glue. Bad. Yes, you can use regular bathroom silicone, that's fine. Okay, let's see if that looks a little bit better on the scope then. because I suspect we do in fact have positive rail, it just wasn't showing up. There we go, see, now we have positive rail. So it was there, we just couldn't read it because we didn't have any ground reference for the output side compared to the main side, the power supply side. So yeah, let's just have a check on the outputs here. Yeah, that's fine. So we're looking for just some class D switching on these remaining channels. See if that works, if that comes alive. Ah, no class D switching. I don't think this is one of the amplifiers that needs all of the channels alive. We do have a constant clip light illuminated though. I don't think this is one of the amplifiers that needs all of them there to start switching. Maybe it does. So no class D switching. Do we have a VCC into the 2092s? Ah. Do we have VCC? So we got negative 27. So yeah, we've got supply voltage being generated. Okay, maybe it just needs the other two fitted in order to come out of protect, and 2092s are a bit like that. So let's just wait for the rails to sink down slowly but surely. Drop some new 2092s in place and then see if it comes out of protect. .2092s are not cheap. This is not a cheap IC to be dropping in. Okay, that's one. Rare. 2092 used to be very cheap. Not sure what happened when they went up. Yeah, it was during COVID, so basically there was a massive shortage. I couldn't get 2092s even if I tried. And since then, although they're now super available, the price hasn't really come back. Well, it's come back down a bit, but nowhere near back to where it used to be. Let's let that just cool down for a minute, and then we can power it up and see if it comes out of Protect now that all the 2092s are fitted. I think that is the case on these ones. I've got a feeling that they need them all there, from what I can recall, but maybe not. Might have some other problem with the supply voltage or something. We'll see. How much DC amps can you pull out of a 3K or 5K amplifier power supply section as a standalone power supply? So it doesn't matter if it's full bridge or half bridge, because we've removed the amplifier. We've removed the amplifier section, so there is no full bridge or half bridge. It's just a power supply. It's a switch mode power supply. So yeah, it really depends. It depends on the make of amplifier and the power supply design as to how much headroom it's going to have. That's a bit of a loaded question. On paper, the amount of amps you can pull out from it, you can calculate using an Ohm's law calculator. If the amplifier is like 3K or 5K, then just type that number in with the rail voltage that you need, and then it will tell you how much current the output section will draw. So then that's how much current the power supply can supply. Right, how's it going? But it will vary massively between amp brands and amp models, because some power supplies are a bit overbuilt, some of them are on the limit. So yeah, it really depends. Alright, are we out of Protect now then? We have all the drivers fitted. Let's probe one of these ones over here that was failed. Let's probe that one. Interesting. We're not out of Protect, so there is a problem with either the supply to the 2092s or something like that. So it's all 4 channels with no Class D switching. So let's take a quick look at the data sheet. What do the 2092s need? IRS 2092. So 2092s need VAA, which is going to be like a low voltage, maybe like 5 volts, something like that. And they're going to need VCC pin 12, and that's about it. The CSD needs to be, I think, low-ish. It needs to be at a specific voltage. The CSH as well needs to be a specific voltage. Yeah, as long as we've got 5 volts on 1 and 12 volts on 12, then it should be trying to switch, provided the MCU isn't telling it to protect or shut down. So pin 1. So we don't have anything on pin 1. Pin 1 VAA missing. That's why we have no Class D switching. Okay. So, we just need to find where that voltage is generated. Let's just get rid of the rail voltage and the caps. I don't like the term "you get what you pay for" in car audio, because in car audio there's a lot of absolute rubbish on the market with massive markups from named brands. So in car audio, you don't get what you pay for. You get what you researched. You can pay a lot less and get a lot more for your money if you know what you're buying. So pin 1 is VAA, pin 2 is ground. We actually have a 50 ohm short there. So yes, something is wrong there, and it could either be what is supplying that voltage, or it could actually be one of these chips. Actually, one of these chips has a freaking hole in it. Why didn't I notice that before? Okay, I think all of the 2092s are dead. There's got a hole in it. I think all the 2092s are dead. That's an expensive 4 new 2092s. Shee. Can we trust this one? No, we can't. It's coming out. No holes in any of the ones I just replaced. No, we're all good. There's the little marker there for pin 1, but no holes. No holes. Alright, 2092. Good job I bought some more of these. I bought some more 2092s recently in preparation for needing some more at some point. And today is that day. Do you think they're dead because they have a hole? Well, I've got a hole and I'm not dead, so you can't always take that for granted. You had intentions on beefing up the power supply way back on the clone. You were reverse engineer and rewinding the transformers. I've been thinking about that project, or at least its power supply. Yeah, so that project's finished. I just got to make some quick mods to the heat sink so I can screw the FETs down and stuff. Just haven't got around to that yet. But the actual circuit work on that mod is repaired. Is finished. Hopefully this is repaired though, with 4 new 2092s. Let's just see whether we get VCC. Sorry, VAA is called on this one. VAA. You're not really supposed to do this. You're supposed to let stuff cool down like naturally. You're not supposed to kind of do forced cooling after you finish soldering, because it can sort of lead to stress cracks and stuff. But that's not too hot, so. Alright, let's see if we get VAA now. We only have 1.8 volts. So So no, not quite, and I suspect we're not going to get any Class D switching either as a result. No, so the supply for VAA seems to have got hurt as well, so let's go in search for that. Let's check the resistance across VAA and ground. So we... Whoa! Why have we now got 10 ohms? We had 50 something. 10. Right, well, let's just see where that's generated. I don't think I've had to go this far back on one of these before. We've got this diode over here, 16. And there, 16. Now that's a bit worrying actually. That's a bit worrying. The resistance is lower by the chip than it is at the circuit that generates it. That's a little bit worrying. We have a capacitor here which has 20. There's something else that's dead somewhere. I'm tempted to grab the thermal imager and see what's getting hot. That's where we might be. I wonder if it's one of these little capacitors. Right, so I'm at the point now where really sort of in order to chase this short, I need to see what's getting hot, or I need to remove the chips again, see if the short goes away, or I need to... Wait, are these definitely 2092s or are they 20957S? No, definitely 2092s, okay, that's good. Definitely 2092s, that's fine, that's good. Ah, okay. There's, okay, it could be over here. So this possibly is the circuit responsible. We've got 10 there. And 10 there. Okay, let's just lift these. This looks like it's got a bit hot, doesn't it? This looks a bit toasted. So let's just lift these diodes here. Now, what are these diodes going to be? Hopefully they're just like 4148s or something like that. Or maybe they're rectifiers. There's quite a lot gone on here. So Finesse, definitely Perry's Amplifier Repair Guide, which is on bcae1.com. I repeat, bcae1. It stands for Basic Car... Hang on a minute, BCA... Basic Car Audio Electronics 1. Basic Car Audio Electronics 1, bcae1.com. That is your starting point. There's a paid amplifier repair guide that you can purchase and download from there, which will definitely give you a massive leap head start and be able to get you fixing some stuff. So let's have a quick look on the microscope. What is this? These diodes are W8. Okay, W8. We go to our favorite website and see what that is. W8, that is, well, it's saying it's a Zener. it a Zener? 4v7, that would make sense. Don't think I've got any 4v7s. So it's not labelled on the board as ZD for the Zen diode, but I don't know if this board does that anyway. So there probably are Zeners. Let's just see if the low resistance has gone away. Yeah. So the low resistance is gone. So they were toast. Oh no, we still have 11 on there. Something else is dead. This capacitor? Oh man, there's a whole lot of stuff going on here. Preamplifier maybe? Because does this supply... Yo! This supplies some of the preamp. I wonder whether it's killed some of the op amps as well. We got some low resistances on the TL074. Bro! This thing is toast! Right, hang on a minute. Damn! I think what we need to do is we need to put a little bit of voltage, a little bit of current into this, across this capacitor, and that will show us what gets hot. And I think that's going to be a task for another day, because it is currently 11:30 in the evening here. Chee! Yo! P4 Innovation with $100! My guy, that is crazy! What the heck? What a monstrous donation! Jesus! Thank you so much, my friend. Thanks for all the help. Literally, anytime. Anytime. Feel free to like message me, anything you need, give me a shout. That is an absolute whale of a donation there, my friend. Massive respect to you. Thank you so much. What a lad. $100. Jesus Christ. Absolute legendary donation, my friend. Thank you so much. Like I say, anything you need help with, drop me a message. bearvids.com/Facebook. No. Facebook.com/bearvids. Facebook.com/bearvids. And drop me a message. And anything you need help with, give me a shout. I'll do my best to give you a hand. So massive thanks. That's a big donation, my friend. Thank you very much. Your generosity is next level. That's a big lot of money. But I think this issue we send some current into, and we use a thermal imager to see what gets hot and go from there. I think that's the solution on this one. Because if something died over here, okay, killed the driver, high voltage went through VAA to here. If this is also supplying voltage for the op amps in the preamp, then basically every single op amp in the preamp could be dead. Yeah. Yeah, my flabbers were ghasted by that, for sure. So guys, yeah, it's been a great stream. Had a lot of fun this evening. Hope you have as well. We're going to be streaming next week as well. Probably streaming a little bit earlier. So basically, I've been doing some morning live streams. Morning time in the UK. Probably is going to be like in the middle of the night for a lot of you guys in the US. But hopefully you can watch these streams back after they've been finished. You know, you can just watch them back on the stream replay. Hopefully that's also fun. So I'll probably finish this off in another stream, like in the morning time in the UK, sometime next week. And we'll find out exactly what else has bloody failed on this. It seems to be a lot, so it'd be fun to kind of get to the bottom of it. I don't know whether the repair is going to be cost effective for the client in this case, but we're going to get it fixed for the stream anyway. I'll offer the repair to the client at the bill, and if they don't want to go ahead, then I can just keep this for parts or sell it on or something like that. Yeah. Use the 100 to buy it. Yeah, exactly. If this was mine, that's what I'd be doing. No, I wouldn't. That's a lie. If this was mine, I'd still be fixing it. Who am I to lie? The streams lately have been great. Been enjoying what I can catch. Oh, I'm glad you've been enjoying it, Gotlos. That's my plan. We're going to remove the ASMR. All the ASMR's gone now of the oscilloscope. It's bare vids after dark. Oh, wait, bare vids after dark. Turn the big lights off. So this is just the lamp. That's how bright my workshop lights are. So this is a normal ceiling light, okay? And it's not particularly bright, but it does the job. But the camera makes it out to look very dark because of how bright my workshop lights are. Bare vids after dark. Yeah, what are you saying? Yeah, cool. I'm going to go and have a cookie and have a drink and probably get some sleep. So I'll catch you next week. Have a great rest of the weekend. Have a great sleep, and I'll catch you up next week. Take it easy, guys. See you later.